all these different things here, what's going on. And what's cool about this is it's been given a task, probably to do the dishes, and is solving this very complex problem to be able to do that. So there's lots of decision and control going on. Have I got another one? I have got another one. Is this a robot? What would we call this? If it's not a robot, what is it?
Machine.
It's a machine. It's most definitely a machine. It's got mechanisms and everything. There is a bit of control going on, but it's, you know, we're talking about speed control and in terms of fuel injection and stuff. Yeah, there's a bit, but it's extraordinarily basic, so I wouldn't really call it control at all. What about this guy? Yeah?
Sometimes they have lane, like when you...
Yeah, lane departure,
yeah.
warning systems,
Yeah.
and actually control of the steering wheel. Yeah, yeah. So how many computers do you think that machine has in it?
30,000.
Yeah, there's 30 odd, at least 30 odd computers in a modern car today that's making all sorts of decisions, and there's all sorts of control. We can change some of this stuff. It's becoming much more active. And of course, I go to the next step, you start to wander up with machines like this. Yeah? This, is, to me, is scary. The idea of driving down the road without having your hands on the wheel. But no, self-driving cars have been given a task, go from here to here, and it has to solve all these different problems as it's going along the way. The human is out of the loop now. And it can actually do very sophisticated tasks. This is most definitely a robot. Does it look like a human? Yeah? Remember that first definition? Does it look like a human? What about this guy? Is this a robot? Nobody has a cup of coffee in the morning? This actually turns itself off when it gets to a certain temperature. So it's got sensors, it's got actuators, it does communication. Well, it might be even more sophisticated because modern home appliances are now connecting to the internet. Yeah? And as you know, in a modern home now, they're monitoring what human activity is, and it'll be turning, it can turn itself on when it knows or perceives that you're potentially going to want to have a cup of coffee. Because historically, you've been turning on the kettle at 8, between 8 and 8:15. Well, 8 o'clock, at 5 minutes to 8, I'm going to turn the kettle on so that when you come out, the water is definitely hot, whether it's between 8 and 8:15. And then after 8:15, I'm going to turn myself off. Modern appliances are actually doing this stuff. You know, fridges are emailing people and saying, hey, you're out of milk. You think I'm kidding? Yeah? Are these robots? I think so. There's lots of interesting things. But at the grandest scale, I think this is my last one. Does anybody know what this thing is? This is my last, I think pretty much sure. What is it?
Is it an oil refinery on the east side of everything?
It's very close. It's not an oil refinery, but it's on the same scale. It has lots of objects that look very similar. It's actually directly, it's over there. Matteo?
Cement plant.
It's a cement plant. It's just, I did my PhD on cement plants, looking at large-scale combustion and big flames. There's a big tube in there where they bake the cement. 6 meters in diameter, 50 meters long. It's huge. Lots of energy involved, lots of mechanisms, lots of power, there's lots of communication, lots of sensors, lots of actuators, and there's definitely a control system because you want to control that flame and the amount of energy and the for the generation of cement. It's a manufacturing plant, it is definitely a robot. But I would call it a mechatronics system rather than a robotic system. And I think robotics today is much more about replacing human activities like grasping things with the hand. Mechatronics is much more about, well, doing activities in a very automated way, using all these different areas. Okay? A robot doesn't have to look like a human. R2-D2 certainly didn't look like a human. But this is definitely what I would call a robot. Yeah, I'll leave that one. I'll leave that one as well. So, is Wall-E a robot? I think in the vision that the animators had for the movie, most definitely, could you make this robot work the way that the movies want? That's a whole different question, because the amount of energy he uses up is actually quite extraordinary, I would think. So, that's it. I wanted to give you a bit of an idea of my definitions of what robotics is, mechatronics is, because I'm very much a push towards mechatronics, as you guys are getting, there's going to be a lot of focus towards the humanoid robot thing as you go through your undergraduate degree. Today, you're not going to do any math, probably. But remember, math is a language. It's not just doing hand calculations. It's not just a bunch of grunt work. We can use it to describe things quantitatively. It's a fantastic tool. But you do need to understand why you're doing a particular system. And having that physical interpretation, actually building stuff, is extraordinarily helpful when you start to design and predict performance of things and you're doing those calculations. So I'm really supportive of events like this today, and I'd like to thank the Albertaloop Club for having me come along today and organising this event, because you've got to get an experience today where you are hands-on, building stuff, trying to solve problems. But I'm hoping that as you go through your classes into the future, you'll be able to look back at this event and go, hey, we did that, we built that. And now we can actually, you should be shown how to predict and how to do the design for that particular thing, rather than just arbitrarily putting stuff together and seeing how it works. Thanks very much.
Or you want to?
Thank you so much, Dr. Nobes. That was an awesome presentation. We're going to take a quick little break for you guys to go grab some coffee or hot chocolate or some more breakfast that just arrived. And then we're going to call up Raymond to help us explain the challenges ahead. So yeah, feel free to go and line up and get some food.
I think the first place was the first place was.
Don't want any other?
You guys ready?
I didn't do it. I'm alive. It's on one diet. Yeah, that's
Ethan, were you on college or what?
I have so many projects now. There's a lot still happening.
Oh, I can. Just you can just first and then
Hello everyone, so we're just gonna start explaining the challenges and rules. If you don't know me, my name is Raymond. I'm a third year mechanical engineer, and I've been with the Albertaloop Club for about 2 years now. And yeah, let's just get started here. So first off, we have the 3 challenges. The first one is going to be the balance beam that you kind of see in the middle right there with the green on top of it. The goal of that challenge is to balance your robot on a seesaw, either manually or autonomously. The second and third challenge will take place both in that maze there. There will be a manual and automation challenge. The goal is to move throughout, for the manual mode actually, just throughout the maze there, kind of. And yeah, just make it to the finish essentially. Same thing for the autonomous. Of course, you won't be using the controller for that one. There will be more detail on scoring throughout this slide deck here. The grading will be evaluated per our judges, and they will be evaluated based on design process, choices, autonomous implementation, and more. For the performance, each challenge is worth an amount of points, some more than others, and this will be described in the marking rubric. And there are also included bonuses, and it varies based on the challenges. So, for more, challenge 1, the objective of the balance beam is to demonstrate your robot's capability in utilizing automation in order to balance on the provided beam. The scoring factors will be speed, faster balancing earns more points, stability and control, which includes smooth, controlled balance, and is rewarded. This will include the wow factor for the judges. There will also be an autonomy bonus, and this will result in a higher score for autonomous robots balancing using a gyroscope and/or a PID. The objective for challenge 2 is to evaluate the robot's ability to be manually maneuvered throughout the designated maze. Some of the scoring factors for this one will be a Mario Kart style grading for first, second, third, etc. So if you end up in first place, you'll have the most points, and then it'll be reduced by your placement. Penalties for resetting the robot or colliding with the maze itself will be taken into consideration as well. For challenge 3, the autonomous portion of the maze, the objective is to utilize a control system and sensor feedback to navigate the maze without human intervention. The scoring factors include task completion, which means make it to the end, make it to each checkpoint to gain points. Efficiency and speed, judges will rate your autonomous implementation via observations, question and answer, and a code review. And there will also be bonus opportunity, which will have your robot automatically stop at the end of the maze. Some general rules here are the number of challenges. You can complete as many or as little of the challenges as you want. For points, each challenge is worth an amount of points, some more than others, and this will be, again, described in the breakdown for the points. And again, with the additional points, will be awarded for your code, robot design, and how you present your design. Continuing on for the general rules, your robot can be controlled in any way you wish. However, the robot cannot be touched during a run. 1 point penalty for each time, and there will be a max of 3 penalties. There are bonus points for performing challenges autonomously. For some things you can't do, the first one you can't do is you're not allowed to cut the wires, as we have plenty of jumpers. And for the servos or motors, please do not take them apart. If you guys do need any help, please look for anyone wearing a Albertaloop shirt, and we are here to help you. Just a little tip here is that it might be helpful to add a strain relief to the controller wires on your robot so they don't get pulled out. And that should be everything here. So good luck, and please let us know if you have any questions. Kind of on the next few slides here are the schedules, and then I do have the QR code for the Discord, so I ask all of you to please sign up here.
So this will include like the grading rubric as well as more information on each challenge.
Alright, and also please scan the QR code for the GitHub as it might contain some helpful resources to get you started.
Yeah, it contains a starter code and a schematic that you can follow through just to get something done. Yeah, and some helpful resources to set up some sensors.
Yeah, and I'd also like to thank some of our event sponsors here. Aramark for supplying most of the breakfast for today and tomorrow's event, and Dewey's Bar for presenting us with some prizes, and also Thornsby Hotel Bar, which has provided us with some funding. For the prizing, for first, second, and third place, starting with first place, we have ESP32 microcontrollers. For second place, we have some Arduino Nanos, and for third place, we have Dewey's gift cards. Along with just some thank yous here, on behalf of the club, on the Albertaloop Club, I would like to thank the Mechatronics Club. They've been super helpful with helping us out, set up the event, and do some of our coordination. So, sorry. I would just, again, like to thank the Mechatronics Club for helping us out with our event. Yeah, I think that should be everything here. Yeah, so we're just going to be moving on to the Arduino workshop here, just kind of get you started on what to start with.
My turn now? Okay, let's go. Hey, you got my slideshow? Anybody? Export, Alex, Gavin? I emailed. They're not ready to go at all. They're like, that's the way to do it. It's a lot more fun when you're not actually organizing. Okay, if I can get your attention, what I am going to do is a quick workshop on Arduino breadboarding. The purpose of what I'm doing is to give you the short and easy, quick things and some hints about the most likely mistakes you're going to make. How many people have programmed with Arduinos already? Some people? Okay. Everyone has an Arduino on their kit, right? And everyone has a computer that has Arduino software, right? Okay, so we're going to follow along, and I want you to actually do what I'm doing while I'm talking. So first thing, what we're going to do is get out our supplies. In order to do this quick workshop, you need the Arduino, the breadboard, a bunch of lights, and 2 buttons. Okay, everybody get this stuff out so that you can follow along with me. Okay, get your Arduino, your breadboard, 3 LED lights at least, and 2 of the push buttons. Okay. Are we good? teacher at Jasper Place High School. Some of my former students are here, which is how I got invited. So I teach Arduinos in high school. We do it to give everyone experience with working with hardware software. So, first of all, we have breadboard, lights, wires, and push buttons. That's what we're going to use for this quick workshop tutorial. Everyone got that open and ready to go? So, first thing you have to know about breadboards. Breadboards are a prototyping device. What they have asked is please don't cut the wires. The wires that we're going to use have a pin on each end. We pin them into the Arduino. We pin them into the breadboard. Okay, as you get started, don't cut the wires. Don't, your breadboards are going to look a big mess when you're done, but that's okay. You have your hand up? Yeah?
Yeah, we don't have wires or anything.
You don't have wires?
All up at the front.
This? Here, come get some. Come get some. If you don't, oh, don't take the whole thing around. Everybody come and get a pack of wires. Oh, make sure you have the ones that are the pins at both ends. You don't want anything that's not the pins at both ends. Here you go. See, someone put up their hand and bravely told us that we didn't have it. We don't have push buttons either. I thought everybody had push buttons. Okay, so this is what they look like. They're not very big, so when you look at what they look like, it's almost half of them there.
IDE is just a place that you write code.
They don't have pins on both ends.
So Arduino IDE is just one really specific information. But platform is this extension of VS Code. So you can use VS Code, and then you need the like side which I think is like yeah, it's a mega. Yeah, effectively. I think you can think of it that way. Platform I always
Make sure that you have
manager that talks to VS Code. Yeah.
Feels like cheap. Okay, everybody has what we need now. We've got at least 3 LEDs, and we've got 2 push buttons, and we've got wires. The Arduino and the breadboard. Okay, first of all, I'm going to quickly explain a breadboard. A breadboard has a lot of conventions, and they're simply that, conventions. They're used to make it easier to work with. So the blue minus is ground, the red plus is power. But they're actually not ground and power until you connect them to your Arduino. Okay, so now pull out your Arduino, and what you want to look at is on your Arduino, we have, on this part here, there's 2 powers, 2 grounds, and a ground on that side. So make sure that you can identify the 2 powers, a ground. So there's 2 powers down here. There's 3.3 volts and there's 5 volts. Your 3.3 will allow your LEDs not to pop when you don't have resistors. If you are going to use the 5 volts, you need to put resistors in so that your LEDs don't pop. So, you know, put it into 3.3 to start with, and then we're good. Okay, so what you're going to do is you're going to take your Arduino, you're going to connect where it says power, and take it on the 3.3 and you're going to connect it to one of the red channels. So on your breadboard, the channels run. So the ones on the two sides run vertically. Everything that you plug into that vertical channel is connected to each other. Does that make sense? All of them are connected to each other. When you are going across, everything within these 6 dots is connected to each other. Yeah? 5. Okay, 5. 5 on this side, 5 on this side. They are separated with no man's land. They are not connected on the two sides. So those 5 are connected to each other. So what you are going to start with is you are going to start by setting up your board with power and ground. So when you actually start with your board, these are just conventions of power and ground. Until you actually connect it to your board that has power and ground on it, you actually don't have anything. Okay? Because they don't actually have anything. So then what you do is you're going to attach power to the red and ground to the black. Okay? So then you are good and you have one side done. Now, one of the things that we often find is that we don't need power as much as we need ground. So one of the things I do is I take ground, do it to the blue on this side, and then I just put a shorter one to the blues to each other on this side. Okay, so now you've got power, you've got ground, and if you just take it, so you take a blue one from this side to a blue one from this side, and now both grounds are ground. Both sides are ground. And only one side is power, because you're not going to need power quite as often as you're going to need ground. Okay? So then what we're going to do is we are going to look at our LEDs. So you take your LEDs and you look at them. And they have 2 legs on them. One of them is power, one of them is ground. And it's always hard to remember, is the short one power or is the long one? So the long one is ground. And if you make a mistake, guess what? You turn them around. No big deal. Okay? So the first thing that we're ever going to do is check our hardware. So this is what an LED is. We've got ground and the pin that we're going to set it to information. Okay? And on the buttons have direction on them, but if you're not interested in how the direction of the button works, if you use the 2 diagonals, you'll always be right. Does that make sense? And when you're using the 2 diagonals on a button, it doesn't matter which one is ground and which one is information, because all you're doing is breaking the information between them. You're breaking the connection. So when the button is up, the connection is not made between those 2 diagonal corners. When the button is down, the connection is made between those 2. Make sense? Okay, so then what we are going to do, test your device and parts. Make sure that they're working. So first thing we do is we plug in our Arduino. When you first plug it in, when there's no program on it, it's power, okay? And you just have power to be able to test your things. So what we're going to do is we are going to plug in our Arduinos into, a port on your computer. When you plug them in, you have power now to your board. Okay, so first thing we're going to do is check and make sure our lights work. How do we check and make sure our lights work? Well, we have to put the lights on the board first. And so what we're going to do is on our lights, we're going to take, let me see, we're going to take, is it the short end or the long end? You never know. Okay, so we're going to put, I think it is, anyone else remember? Mine are all done so that the short end looks like the block, the ground. So we're going to line them up in this channel so that we don't have to have a bunch of extra wires. Okay, so you're going to put the short end in here and the long end directly across from it. Everyone got that? So you're going to take the short end and put it in ground. The long end you're going to just put out here. Okay? And because I brought my own battery, I'm going to directly power so you can see what I'm doing. Directly power my Arduino. If I've got the power on and it's set up with ground to ground and power, so I've got ground to ground and power to power. So then what I can do to test my lights and see if it's actually working is I can put another wire into the thing and just touch my lights. And if I've got them backwards, I should be able to just touch them and see the light come on. Okay, well, I'm doing good so far today. Power, just touch them and make sure that we have ground to ground, power to power. Oh, my battery is not happy. Looks like you have lots of batteries. Okay, so test your lights and you should see them come on. If they do not come on, it means that either you don't have your connections right or you have faulty material. Okay, so you got power, ground, ground. This is power to power. Everyone tested theirs? Got them tried out? You see the light comes on. You want to make sure that your light actually lights up and then you've got it the right direction. Okay, light. The worst thing to have happen is you're trying to write a program to do something and your hardware is actually broken. And you're like constantly trying to fix your program, but it's actually, the light actually doesn't work. That is very discouraging because you waste a lot of time trying to figure out what's going wrong, and there's nothing wrong with the program. Okay, does everyone have their lights lighting up? Everybody? Yes. Okay, thumbs up. Let's go. Everybody thumbs up. We got lights lighting up. Okay. So once you know your program is actually working, what you are going to do is we are now going to put the first program onto our Arduino. So plug it into your computer, and what we're going to do is make sure that our board is working. If our board can't take a program, we're in big trouble. because we need a new board and it needs to work. Okay, so what we're going to do is open up the Arduino software and we're going to connect the board. So we have to connect it using, this is an old version because my computer at home is running something old. So you're going to go under Tools, Boards, and choose the Arduino Uno choice. Okay, under Boards, Computer, Boards, Tools, Boards, Computer, or the Arduino Uno. Okay, under Port, you should be able to select the port that the Arduino is connected to. If it is giving you port 3, your port 3 is always your screen, it means it is not connected to your Arduino. Put it into a different USB port. Has everyone got it connected with the port showing up correctly? Yes? Okay. Thumbs up again. Have we got it? Everybody's got it connected to the right port. Anyone need a hand? We have lots of people here who can give you a hand. We're good? Okay, so we've got it connected to the right port. We're good to go. So then what we're going to do is we're going to pull up one of the example programs. The first example program to make sure that your Arduino works without worrying about any of the board, the breadboard, is Blink. So go to Examples, Basics, and Blink. Bring up the Blink program and upload it to your board. Okay, bring up the Blink program and upload it to your board. So when you upload, there's a check mark over there and there's an arrow. The check mark just compiles it, make sure that your code compiles. The arrow that goes that way uploads the code. So what you want to do is upload the code. As soon as you upload the code, this built-in light right down here is going to blink, blink, blink. Then what you're going to do is you're going to change these delay values. 1,000 is 1 second, so they're in milliseconds. So change those values. Make sure that when you upload it again, it changes on your board. Okay, everybody do that? So upload the code, make it happen. It should be blinking on your board. Okay. Got it? Okay, then what we're going to do is we're going to take a new wire and put it from one of our lights on the information side that we tested, and we're going to put it into, so if we go back and look at our breadboards, our Arduino here. So the green part here that's highlighted is the digital pins, and the red or the orange down there is the analog. We're going to connect them all up into the digital range. So which pin you put it on only matters to you and your code. It doesn't matter to anything else. You just decide what you want to do and you start putting them in. So usually what I do is I start with the lights on one side and I start with the buttons and stuff on the other side. So we're going to start with the light at 13 and we're going to connect up the buttons to 2 and 3. Okay, so we're going to take our wire and connect it up in line with your, so we're going to connect up. So we're going to connect it up in line with one of these. I put this one on the other side. This is using Tinkercad circuits, and they don't let you rotate your LEDs. So you're going to put to, well, in this case I put it to 6. I usually put it up to 12. 12 or 13. So you just connect it to wherever you want on that digital pin side. And then once it's done, you're going to change your program. So you're going to go back to your program and you're going to change your program so that it reflects. So now you're going to change your program so that it reflects where you plugged it in. So you're going to change LED built in right here and here to whatever number you put it into. So if I put it into 13, I'm going to put a 13 in there. If I put it into 6, I'm going to put a 6 up there. Okay? And then we're going to see that light blink. Okay, everyone got it? Got lights blinking. We can change the pattern of them blinking. We just change this to this number here to whatever number you want to make it on your board. Okay? And then what you're going to do is say, well, if I can do 1 light, I can do 5 lights. I can do 3 lights. I told you to take 3 out to begin with. So plug in the 3 lights. Add code. What you're doing in the setup, if you're looking at setup and loop. So if you look at the basic code, setup runs once, loop runs over and over. Above the setup, you put any variables you want. In the setup, you're identifying what you want it to do. So when you're saying pin mode, LED built-in output, you can put pin mode, number 6, number 13, number 3, output. And we're putting it as output because we're going to write to it, not read from. So most of these ones are read or write. Some of the more complex ones that you're going to use are read and write. So that's a different kind of input. So then we are simply doing a digital write to that thing. High is 1, low is 0. High is on, low is off. So you turn your light on and off based on timing. Now, one of the things that you're going to notice when you're doing robotics and you're using delays is delays are a great way to, do the timing. But if you are expecting to have quick interaction with your board and you put delays in, the code is actually stopped at the delay. It isn't going to continue looping when you put in a delay. So if you say delay 1 second, it is going to sit there with the light on for 1 second, not checking any inputs till you're done. So one of the things we often want to do is not put delays into robotics. This loop is running approximately 1,000 times a second. So it is checking for inputs and outputs at 1,000 times a second. So if you put a delay in for a second, it's doing nothing during that time. Okay, make sense to everybody? Delay means code stops, nothing happens. Okay, then we are going to do a quick look at what the buttons do. So now we're going to put in buttons. Now for the buttons, as I said, put them in on the middle so that they're half on each side. That way there's no interference. If you put them in incorrectly, it doesn't hurt anything because they're not going to interfere with each other. So putting them right in the middle is a really easy way to control that it'll work no matter what you do. Okay, so put in 2 buttons, and then you're going to wire up your buttons. So one of the corners on the diagonal, you're going to put to an information, and one of them you're going to put to ground. When we're putting things, the buttons to ground, we're going to do an input pull-up. When you put them to power, you do just an input. So it's two different ways of reading a button. You can read it as an input pull-up, or you can read it as just as read. One of them you connect to power, one of them you connect to ground. So the button is the same whether you're breaking the power or whether you are connecting it. So here is what we're doing. If everyone got this, you connect one corner of the diagonal to ground, one to one of the buttons that you want to do. The easiest code to do on the button, okay, so first of all, we're going to just quickly talk about a serial monitor. What a serial monitor is allows you to write to your computer so that you can see what's happening on the Arduino. So while your Arduino is connected, if you open the serial monitor, it allows it to read and write information that is happening on your Arduino. So there's a serial monitor button in the corner, and it opens up a big white section at the bottom that will only open up when your Arduino is actually connected with a program on it. The important thing here is to change the baud rate to 9600. The baud rate is the communication speed, and the communication speed depends on your device. So if you're working with a simple Arduino, 9600 is its speed. When you're working with the faster motor controllers, they have a faster speed that they're going to work with. Okay, so it depends on the device what the baud rate is. So then what we are going to do here is we are going to go to a sample program, and then we're going to integrate two sample programs together. So we got our Blink sample program, and now we're going to go back to Files, Examples, Digital, and there's Digital Pull-Up. We're going to grab that file, and we're going to add the code into our Blink. Is everyone ready for this? Yeah, so we're going to have two files open. We're going to take some more sample code so that we don't have to type it all in, and we're going to get it working. So this is what the code looks like. In the pull-up code, it has pull-ups here. So the first thing you're going to do is serial.begin, and what that is doing is it's setting up the serial monitor to be able to talk. If you've done any kind of coding, you know that print lines are very convenient to be able to print what your sensor values are. Is my sensor working properly? Am I getting the values I hope to get? A print line is really useful to be able to do that. It'll save you a lot of time. So we set up the serial monitor in setup, and we set up the pin mode, and we're using 3 and 4 here, and input pull-up. So we're telling it what we're going to get from that button. So we've connected the wires, and now we're saying this is what we're going to do in code. So in the loop part of it, we're going to add the read the button value. So we're just going to digital read from 3. And then we are going to say if sensor value, which is digital read 3, is high, that means it is not pushed down, we're going to turn off the light. When the button is pressed down, which is low, kind of makes sense, you're actually going to turn on the light. So what's going to happen is when you put this code in there, when you push the button down, your light lights up while it's down. When you press it up, the light turns off. On, off, on, off, on, off. And now you'll notice that we took out all of the delays. So if we press it faster, it's going to go on and on faster, on and off faster. It's not based on a delay. When you're doing robotic coding, you want to get rid of delays as much as you can. Do I need to slow down? Are we okay? Followed? Okay, so now we're thinking about the second button. So the first button just basically does on, off, on, off. Okay, when you're doing the second button, now we're going to make the second button a little smarter. Because that on, off, we could have just accomplished by wiring it electrically. Right? It didn't really need a program because we're just breaking the circuit, it turns the light off. Connecting the circuit, turns it on. Simple, right? But now we're going to make it a little smarter. And the way we're going to make it a little smarter is on the second button, what we're going to do is we are going to say if the value changes, so it is when it is pressed down and up, it's going to alter whether it's on or off. So now your light is going to be a little smarter. When you push and release the button the first time, it turns it on. You push and release it again, it turns it off. That's a regular thing that we think is a useful thing. So a little more difficult in coding because what we have to do is we have to know the previous value of the button and the current value of the button. So before in the loop, I put a bunch of variables up at the top so that instead of using the numbers, I could just use names. You can always use names instead of numbers. It's the same thing to put the numbers with the names. After you're doing it a while and you might want to change it, it's really convenient to have them as names instead of numbers. Okay, so up at the top I put button B value. The P means previous. What was it the last cycle? Okay, and button B value means what is it going to be currently. So we take the previous value from the current value, then we read a new current value. Okay, if the previous and the current values are different and the button is pressed, that means that previous to this, loop, the button was in a different place, and so we know that we just caught the very beginning of the press. Now, you understand that when you press the button and it's running 1,000 times a second, it's going to press that you've held it for many, many cycles through the loop, right? So, you only want to catch it when it's changed from one run of the loop to the next run of the loop. So then we're saying if the button value has changed in that, millisecond, and it is now low, we're going to, so lit, unlit means if it was on, turn it off. If it was off, turn it on. Okay, simple. Okay, and then we're going to say if it's lit, yes, I hear people giggling. Digital write, we're going to write to light number 1 and turn it on. Otherwise, we're going to turn it off. Okay, so this code just helps you understand that you press the button on once and it turns it on. Press it again and it turns it off. Okay, anyone have any questions? So basically that's all that I'm going to cover right now. That gives you your very basics. I can walk around and help anyone that has any questions. When you add push buttons, when you add servos, when you add any of the other things, it's just more of the same. Okay, it's more of the same. You're going to connect them up, power, ground, information, power, ground, information. The easiest place to start is always using an example code, get it working, make sure your device is working, and then you move on and integrate the next thing. Okay, when you've got good working code, save it, save it, save it. It's always good to have a saved copy because things happen. And the other thing to note is if you are wiring something and you create a power to ground situation, your computer will turn off the USB port with a breaker to protect your computer. Okay? So if your Arduino suddenly fades out and you're like, what happened? It was working, now it's not working. It means that you have created a short on your board. Usually right here. Okay, you've created a short. Unplug what you just plugged in, and probably you shorted a power to ground somewhere. Okay, your computer is protecting your board is protecting your computer. Okay, so if your board fades out, it means that you have a situation that you need to fix. And fortunately, the new computers are all protecting. I have some blackened issues on my desks where the kids were sure it wasn't shorting, and they put a battery to it because their USB wasn't working, and they burnt it into the desk. Don't be those people. Don't be those people. Okay? Find the shorts and don't let it go. Okay, that's all I was going to do for a quick breadboard crash course. Does anyone have any questions? Okay, let's go.
I don't really know much about it. Oh my god. Just use their magnetic.
No, don't text me.
Aluminum is not even
I think another like.
because it has to be iron, nickel,
Okay, thank you, Ms. Parsons, so much for that awesome presentation. We really appreciate it. Now, I just wanted to say that this is officially the start of the work period. You guys are free to get started on that. Looks like most people already have. If you need anything, come up to this table. There's batteries, wires, and like nuts and bolts and stuff, whatever you might need. But yeah, good luck. Feel free to get started and ask us if you have any questions. Oh, and also there's a surprise challenge at like around 3 o'clock today, so don't want to miss it. Thank you.
We have one already. That's what he was doing while we were so, right now, I think what they're doing is just trying to make we were here so we're trying to just right now,
Might be able to just change it to the Arduino.
Yeah, we were just using platform IO and VS Code. We're just planning on using platform IO and VS Code.
What is your thought? Like your autonomous system. There's a bunch of stuff on the front. I think you guys have already found it. The only things I'll say is there's limit switches up front. You get a gyroscope and in your face. And then with the, I guess the rating from the judges, part of it is you'll get a lot of points for distance. You'll get points for whether you can autonomously complete that maze, and even more points if like your system could potentially scale up system.
Yeah. So yeah, if you're not just like hard coding, because it's not really.
So you'll get points for hard coding.
what happened?
Okay, in terms of autonomous systems, if you program your robot to go forward 10 seconds and right 5 seconds, that's like, you'll get points for that, in terms of not being manual control. You'll get more points if it's like, if your robot would be able to solve anything. Or like extrapolate. Depends on how much the judges like it. As well as like performance.
Oh, it's at the front. Now, how do I detect if there's a
I think you guys
channel?
have seen already, there's a mouse at the front, basically, as well as
RF transmission status. That's okay.
Yeah, it's like basically the
in terms of like you the judges look at the autonomous system, they'll do like a
and then game
if you can autonomously complete that, that's going to have obviously and even more points if your control system can be extrapolated to do like different mazes potentially.
They have very
Might be just a button. That makes sense.
They actually do have a remix now. Like your Apple. Yep.
You're supposed to be 100 pages for 9 boxes. They just wrote it off.
Oh,
That being said, right now, it's just test code.
that was 100. Channel 3, no transmission.
Yeah, that's the thing.
As long as we get a high quality panel.
Oh, yes.
Yeah, I like this.
Which one is this? Maybe you just have your Alright.
I'm trying to go towards
Yeah, we can press that.
I think it's F4. And they're spinning way better. That's weird.
Add something extra into it. See how it works. Add some value. Okay. It's all good. Need help? I'm going to be here for a couple minutes. So the most important thing is
I still have access. Yeah, the physics and the wiring.
if you don't have it lined up on the board,
No matter how technical it is, it's not gonna run. Yeah, that's me.
and so I still have one. I don't know how.
And you have the Fredo later.
No, I don't.
No?
I never did.
So you gotta look.
I never had it. They can't change it. Oh, yeah.
Whatever.
Yeah, maybe it's just like it's not.
And it's
Yeah.
1, 2, 3 on
Yeah. So yeah. So put that into the chocolate. Yeah. And the variable declaration supplies ready for the that's in there.
I got it working.
Yeah. No, I'll try to set.
I installed Arduino IDE.
Just so that they're local. And then
I had to start with downloading Wi-Fi drivers. Here's the best part. I have Mac OS and Windows also installed.
if you have pictures in,
So I'm trying to learn Arch Linux. Yeah.
it's really tricky.
Yes, you Maybe I removed Windows.
Hold it more than a second for it to register that it's a second and then you've got 2 seconds in there. So you gotta hold it for 2 seconds.
I think it's perfect. Yeah, I did remove Windows. You can do it.
Okay, you guys good?
That's nice to have. It's nice to have using Apple applications and Apple machines. I never used the Apple text editor.
So you can do like
You could, but that's
no, it's not. We also have a range finder.
it's a little like Sonic, right? And so like what 20 minutes?
Well, no, it's one directional. So here's my thoughts. We have things kind of, the motors don't really make sense because when you move forwards, you breathe and spin. So it only spins when you're so the code is there. But that's something we can fix. So our motors work. And our stalls work. Very terrible. And our joysticks. So I think that next, trying to get it somewhat decent.
Josh probably had it.
But maybe first we can do a little program to see what we Oh yeah, so this is a rangefinder. Basically it's an ultrasonic sensor. Oh yes. It's gonna go like and so this is really ambitious. So like in theory you could put this on like a little and do one full rotation, and that would be like one LiDAR scale. Right? And then you could run, in theory, you could use SLAM to build a map. Unfortunately, simultaneously
Remove all the microchip stuff.
you need like huge power to do that. And so I found something online called Tiny SLAM. And so it's definitely worth it. But I don't think it's going to work.
Yeah, you have to know it. Be careful.
Did the motor get called?
Well, in a separate machine.
So who did you give it to? Like you would?
This one probably does. We don't have I think they have a specific stepper motor.
Yeah.
Oh, the pine song. Yeah. Yes. I have a
And that's very
We're at about 20% left for lunch.
USB-C power. I would have gotten the pine song.
Yeah.
There you go. I think it was like $50. I think it was like $30 or $40 for shipping. It's a USB power.
Okay, that's a feature I can tell you that what you can do, and this is like really simple, is let's say you're able to build like a map, basically. And you're able to see, imagine like 2 different squares.
Yeah,
If you see like an obstacle, like you're able to say this square is an obstacle, you can turn it to 0. And if you see, no obstacles, then you turn it to 1. And if you don't know data, which is basically just like starting on X or outwards, and then finally it has a negative one, and just like it really doesn't have to be it's pretty advanced. That's like fun for those.
Always there's 25
just get a
that's a jazz.
and it's pretty simple. It's PID for proportional integral. And so imagine I'm on a line and I want to get into this the proportional term is going to say I'm 5 dots away from this square, so I'm going to have to respond into 5 dots. And then here it would be 4 dots. But in reality, if you just do that, you're going to like oscillate on each other. Because you're like, I'm really far away, I'm 5 dots away. You start going this way really quickly, and you overshoot it, and you're like, 5 dots away this time. You just end up going bouncing back. And that's where the D is derivative. And you're saying, okay, if I'm going this way to really like towards it, maybe I should slow down so that I don't overshoot as much. And then the interval term is the theory over time, you might get going around a point, and you'll start to branch. You'll start like oscillating. Integral term is happening, sort of like and they'll try and keep this yeah, it's the correction. And so, I mean, it still sounds complicated. Taking derivatives here, it's like, plus equals this, minus equals that. So for those, it's pretty easy. And so, I think 99 is certain that is the way we can movement if we're doing it because it's simple and and they're trying to just always one motor. I'm like,
We've only used like 300 grams, honestly. I'll be dead ass.
We didn't get into batteries are so much better this year, but having like
There was 2 containers.
I can't help you with that. It's already a makes things so much easier. Because last year, okay, the thing is though, once you get into the we did try it. We got it working once or twice in testing, but it was really so I mean, we tried it.
Is there any recording, or is it literally?
Yeah.
So you have to make it. Okay.
So I think this time. Okay, so we need to get like usually we get things announced in there. It's just someone can make it. Like I think like save us minutes for this, right? And then another 2 miles here and here to go this way. So realistically,
If these are like turning, you're gonna be turning.
it's a lot of friction.
It is. It's in here.
Because like other things like that's just one thing. Like you have another okay.
It goes over like stuff that we can't use when you
I do have. I do need your advice on how to
use like AI and stuff.
the GitHub project. So when can I confirm my understanding of this? What we're gonna do is create different files. And then we'll have a main file, and then I don't know, maybe someone will like create like buzzer.h, buzzer.c. So you create your new files, and you'll work specifically in those files and try and be pretty disciplined. At the same time, we're creating a new branch for buzzer.h. We're working that branch.
So for the balancing one, we only have 2 minutes. It starts partially off balancing, so it has to stay there.
Okay, like that sounds good. No, I thought. Let me punch what I have right now.
I got the wheel.
And then you guys can pull.
Yeah.
Let's go.
Where'd this make out?
It's in one of these things. Like a little plastic box. It's in our kit.
Do we need to connect it to the sorry. I think okay, I'm just here, but we
And then these dogs stop working in master.
The thing is, do you think the power range
it does not look like these stars.
So
Well, so what we can do though is because you can show individual snaps. So it's the horizontal snaps. You know the angle of that because it's at 60. It's 64 snaps per testing.
okay, that's fine.
That's fine. The thing is, the one thing I'll initial state is to make sure that the initial state
Something on this side, so we can put the battery directed to this side. That's here. So then it distributes the tape. Maybe we can sort of. Okay,
What if we go tricycle?
if
Take that and we just put that.
we can do some sort of calibration.
Tricycle.
It'll just spin. If you pull something in front of it stops when it exceeds a certain distance, and that's how we can give it. How do we get all the
Yeah,
wires?
but like even then, it's gonna get unless your thing is tiny, it's gonna see that thing before it reaches.
You're right. It'll be enough. We can figure it out. That doesn't look like a good idea. Put on the so I think the plan is to just push right. Because the carpet. And I think the idea is to try to not work in masters when possible. So if someone wants to work on a gyroscope, they want a certain premium branch, in that branch, you can make it bring more out. And again, try and work exclusively. If for some reason, well, then we can just have some sort of thing that might cause harm. But what if we try to make it and then as well, try to avoid errors, we can just like, I mean, it's good to know. Oh yeah.
Which mode is tech?
That's why we need. That's why we need to do the coding. So you're
We don't have a way to
Maybe we can try and put it.
are we? Is that what it's?
It has a metal piece. It's just, you know what I mean? Because we actually do have it. So I think like right here.
if we stop there, so we're doing 45 degrees back.
But those bolts are only compatible with that metal bracket, right? They don't fit through. Like these bolts here, you get with those ones, but those ones can't fit directly.
This motor had no bolts.
Yeah, this one has no bracket. Oh, did you find one? Oh, we found a bracket. Okay, wait. There's screws there. Wait, don't you need mini screws?
No, sorry, it's a zip tie.
Or did you say zip?
I see zip tie. Just know the cars might be the shit.
They just don't want to play together.
Like there's nothing in between. It doesn't give you any feedback on the sensor. It's just you know that when you power it, it will rotate by some sort of function. Because that's what it says in the data sheet. That's just how a stepper motor works. It's like a servo when you power it. This actually it steps. So you go from here to here when you power it, and then the next time you go here. And again, every time you power it, it makes like a single step in clockwise rotation or counterclockwise. What is this? Right? And because you know the step name is consistent due to like the mechanical side. But now you just can predict where you are very accurately if you know your initial state. Yes, and so definitely the problem is that you need to know exactly where you are when you're starting your rotation. Otherwise, right, if the system thinks that it's, it's facing this way, but your sensor is actually facing this way, if the robot is like out of, like it is offset orientation, right? The IMU, you think it's the game, do you have the IMU? I don't know.
Send it on Discord.
Yeah, maybe. How's it going on? I should have called Jackie. Yeah, I think we should try to see if we can set this up here. We can keep going. Because if we can get this set up, would be. It's on It's on here somewhere. Look at the. It's here. It's GY 521. Yeah.
Okay, so Alex, I'm going to grant
We could just like it also says there's a stepper of H.
Sorry.
So do you teach not cooking?
Oh no, we have 3 broken ones. There's another one here.
Guys, what's happening to the motor?
So you should be able to do 5
well, there's 53. I mean, that's okay.
So you should just be able to connect your final.
So why are we starting judging at 3:30 yet? It's not going to take 4 hours. It'll take us 'Cause I need to be out of here by.
You are asking the answer is not that.
Yeah, let's go grab this.
What? Oh, this is an order. This is a schematic. It works this way. Yeah, it does that. I was just thinking like how to mount it. Maybe I just need. There's a little shield. I'll just put everything in the top.
I can do the chip art. It just it's like probably this one fires oil, basically, yeah. So they do show. So you just do digital outputs. Yeah, you just do digital outputs. So what they do here is they there's a stemmer practical demo. Each of your is it like this way? One and 2 and 3 and 4, and then it should just give you stemmer defined stemmers or replicas. It's a stemmer.
The thing is, I don't know how to get to work with this. Like, no, it makes like less than that. But we can just go to the market. It's full. Yeah. So it works. Oh, you're right. Yeah.
Like I think I'm just a loser.
Maybe the ground state.
Like, just look up YJ.
check the battery. That's the issue. Alright, it's on. I think that would work. Oh, yeah. We're so smart. Oh, yeah. I'm smart. I put in one of the batteries the wrong way. Wait, try. Yeah, we're so smart too. No, but not about getting it to work.
Just like look up stuff. Like it may not be a standard now, but it's like definitely not just from them.
So if that design doesn't work, we put this here, we use it to make a small wheel, and then we just turn this, and we have our wheel turn.
A little bit of both.
Yeah, or even a that's my idea.
It might be a bud.
Yeah, like how it happens.
too. That too. And we want to go with like
I don't know if I like
it's supposed to be material. Like have a big motor, like this is like 2048, and then it should be doing one right have like it's not if you want to go straight, then you know both right? If you want to go left, then you want to have the right motor moving. So, right? If you want to just left, which it does. Okay? Yeah, but yeah, the thing is, we have to. Yeah, we have to get it so that the controller works with them. Because now the motor, the wheels are going to spin.
No.
How much would perform? So it looks like one direction is faster than the other one. Watch this. So it started with a flat. I'm actually real surprised that now it's done. The joystick. There's no like it's like 270. Get in a remote control. Bang.
Oh my god, the batteries are dead.
90 degrees. That's tough. There's radiance. That is tough. The speed is actually changing. I don't have a speed.
I just looked up.
It should say right here.
I think acting why do you have like variations of the same thing and you're like,
I deleted the speed.
oh, it's just on there.
Maybe just set the speed. Right now it's just firing.
Oh, we got power guys.
Okay, so I don't think we can continue with the design of this until we see what the motor configuration is. 10 RPM, so it should take 6 seconds. Seem like I'm doing nothing, just sitting there. I feel too judged by my design. And it feels like I just sit there and do nothing and watch. So the speed that's not even in our group. It's not even in our group.
Okay, so I understand this though. Oh, there's fine. Say this, and then we say, okay, we're
but how can you change this one? Now it's just a 360.
to get
Read A0. Is that a thing on the board too?
no, that's like
It only goes one way.
so we're giving this term what is AC? And that's the x-axis.
Yeah, x-axis for the controller.
Why? That's picking the wire.
I think they just made it cause, yeah. Yeah.
Find that, and then we have x-axis and y-axis.
5 RPM.
Chips on my laptop.
Yeah, exactly. Yeah, yeah. The low, high, low, high.
But then I can't
doesn't need to be called 3D. Like, you just want to mark that. You could just label it like, I don't know, gyro tutorial block entity. Ideally is the file.
Like having 3 with a little bit. Like 2 on one side and 1 for the other. I think it would work. Was that because there wasn't enough like, supply on the side though? Because if you have 2 wheels, you have 2 wheels up here, right? It's not fully good contact.
Oh, those are just the neighbors.
Yeah, maybe it's like not too true. No, just the thing like we have two separate like but these ones are 2 separate ones. And then just like thinking I'm thinking up to the joke.
Because like, correct me if I'm wrong, but he gives us the step in here, right? No, I'm trying to think. So you know, 360 having Wi-Fi to step in time, right? So just say like the 5, and this gives you the number of steps in rotation, right? But I'm pretty sure
like this just 2 wheels, right? And just having like it's like inverting the turning, right? Like so like don't want to turn left, right? Just have the right wheel
steps towards the kernel here by set of intervals. So it's 1 to 64. But no, so it should just be 64 times. Yeah.
Whereas also like in the because the original design was kind of turning this way.
I don't think it'll work.
I don't think it's won't even spin.
Change the power and yes. I'm pretty sure. Is that a confident yes or like a...
That sounded like a confidence yes.
I think yes, because that's what it says.
Yeah. Where does that confidence come from? Is it really confidence? Or is it air?
I'm thinking it's yes though, because I forgot that shit for a politician response.
You're so right.
And then it's the motor interface that I recorded.
I'm gonna probably like mute the audio. It looks like we're smiling and laughing, but we're just talking about something.
I think yes though, because these are that's what it says the code does. Because if there's like a back right 1 and 2, so you I could make it go make it so counterclockwise very high or the other way very low or the other way high. So I'm gonna retry the again. So when the code here we have
okay, acceleration is
right? So you have back left 1, back left 2. So we're saying that back left 2 is going to spin back left 2. And we're saying the other 6, 0. But we know this time this is 0. So I think it can spin either way it wants. I think yes. Yeah, that's what I'm saying. I understand. We're so bad. We're gonna.
How's that thing?
We're getting that Dewey's get.
Yeah, I want that Dewey's get from bad.
How many groups? Remove 7 of them. Move 7 of them and then leave. We're gonna try some sort of like.
Are we using what they use? We need to do. Okay, understood. Sorry, I was thinking you were doing it. I don't know what that was.
You got like 3. You got like 2. It's from the club, bro. Holy trans snap.
This point deduction for
Yeah, it should do a full
is up to
rotation.
like 3. If we just get 1 point deduction, we get 1. One point deduction, just remove the wheels.
Or what if we just move the thing?
See how the gyro works exactly? But
Yeah. So we can literally just make out that like, right, if the act is moving, then it's counteract. Yeah. But maybe it's like that, how fast the other go, the other. Or actually, you're gonna get a design. That's what
like you should wait in that sense, but I just want to like
For literally this training, we just power this motor, power this motor.
Yeah, exactly. Well, we love this.
What for the training system? We just, because we're going to make like the Mechatronics one, Mechatronics would work. We just turn this one on and turn this one on. We have like some sort of rotating concept. Yeah, well, like just turn this, yeah, turn this.
so you don't do
Yeah. I got it.
That would work, right?
We should.
But those are like rolling wheels.
Yeah, that's rolling. Because
you have anyone from that truck? Did we refill it?
Are we allowed to disassemble it?
This is definitely more for video.
Like, takes the motor off.
Why is it so tiny on?
Right, because you said the pump won't spin on the motor that has it, right? So then,
What he's saying, this is a big idea. So what he's saying, I think, is like we just use two motors.
yeah, you know what I'm saying? Yeah, exactly.
Motors, yeah.
Because if those are the only two wheels he wants to control, then why do we need the motor? Unless they're actually driving the axis. Yeah, no, so if you want to go straight, both motors. If you want to go right, the left front wheel is on, right?
We can't turn it. We can get you in this way. So. Because then it's like more modular, and then it's like they try.
No, it doesn't.
I feel like it'd be easier, right?
They said to try to use the servo instead.
Don't give up everything. Don't give up. That's wrong. You think you live in a world where you can speak up? No.
It says in the thing here, it says this Brian if you want to mount for your ultrasound, right? It has to just be the one.
Just look up a quick tutorial. Pop up.
I'm not gonna lie, I was so cool.
You're not very cool that there's two that you're doing.
I'm good.
It seems to work. It seems to work way better.
It might be good. It's good.
Yeah.
I think so. But so is this sort of
Oh, God.
I think to boost your speed, this seems to work.
Should we just take a spot then?
I'm gonna try to speed up one.
Yeah, you can figure it out.
Here you are.
Just like
You don't know?
I got the ISIS.
I don't want to say anything.
It's okay, we could just put the pizza in the trunk and just pray it just doesn't.
You can see each step.
So maybe the number of... Oh, it's because you said it to 128 steps.
I upgraded to 1,000 speed.
You want to screw something smooth? Left, right. That's why you want to fire the only two.
You have to make them all this.
I don't know the server.
You guys do it. Try to wire.
You can control like positional rotation.
What are you doing, bro?
Oh, you're reading. You're figuring out how it works.
Get this history. I like the small meals. Another one drop right there. Oh. Okay, now we're gonna put this stuff in.
I don't think we'll have any like. It's probably gonna do like
Two rotations. That's fine. Which is the stupidest thing ever. And tight. So that's right here. It's too soft. You need to watch the sample rotations of us. So this is rotation 2. That's the stupidest thing.
Yeah, it's okay.
Should I go put this in the other room? Do we need this here? You want to just try the Right now, depends on it. Yeah, this classroom some people back.
Oh wait, this is the height of the arena. Maybe we have to make a whole box. I think if we just keep it, like if you have the servo sitting on there, it's.
But now, precision it's not rich because like there's all these wires. I was thinking about that, but I think they'll call distortion. Yeah. You'll just look at the ground.
Yeah, right? Like, it's just like, if it's in there, they can wall it.
Is there any way that you can flip this over?
I'm saying like this and this.
Sorry. Alright.
Flip the casing over so that you mount everything to the bottom. Well, I guess you just tie it.
How does that change it?
Because it keeps the wires in. You don't need that.
Then the wires are going to be dragging around. They're going to pop out. You don't want to do that. The wires are just fine.
But if you just
We can't say tie wires.
that's my solution.
Okay, well this stepper does work. We know it.
So we could probably do it like I think that's fast.
It'll take like 4 years.
I think we're going to move the speed to like 4.
It'll do 2 rotations. That's the problem.
There's no happens for rotation.
That's what it's called competition. Cooking hack. It's actually slower.
I just hung around at our class watching actual font size units. Hey, oh, sorry. I was just watching the
I love that.
So it was 2 and...
Oh, it didn't. So,
Oh, it's still going, right?
no, it stopped. Try having the number.
Wait, no, this works.
One gauge just see I think it's not. Or is this the same thing we're getting?
look over there.
Hey, you got yourself tied down?
Yeah, we'll have to fix this.
That's what I threw at you.
I don't know why. I thought you threw wires for a second. I was like,
This is the last thing we need to do.
Maybe if we grab a really. What about the circle?
Are you done motoring?
hey, stop saying no one is questioning. This is like having it on live.
On the closet like that. Kaylee used the coolest expression of the door open and grab cash and throw up the first figure out.
So you got like a header. There you can put a bunch of
Oh, red lights. What happened?
Why can't you be like this?
Why are we connecting these actually? No, it connects here.
Random value. You can tell it's his.
Yeah, it's literally random values, I swear.
Maybe we can do that. Maybe that's why our thing is we can count with wires.
Yeah, no one is. We might be the original one.
That was a stupid error. Better. Something I would have done too. Why is it not working?
Okay, I believe it. Already connected.
It wasn't exactly.
Our wiring.
We said it came. Good job, guys. Good job.
You don't have to lie.
Well, the battery. There's no batteries. You guys have no batteries?
How many more batteries? It's not the hot. It's the wire itself is now.
I mean, honestly, it's.
The new one.
I'm gonna borrow you. Think of the money we can make. We could throw.
Hello. Do we have an extra controller? Just for fun?
It's easier if you're the one for
So maybe we just.
I think it's pretty unlikely. We can try. Can you do slabs or just like holy you? I think it would be come up with like
The final topic.
No, it might be actually right there. So you're like,
What's our biggest one?
well, here's the step. Yeah, what was that? Yeah, but like, okay, we can maybe ask stuff on time. Like, is it on campus? Can you just like assume that it was something around? That might be okay. No, we're about the same. Yeah, it would be, but here, just see how. Let's look how recent. Is it mushroom Swiss? Put it in.
What's our hat?
Holy gee.
That's a suspension. Get out. No, I think it's
It's most definitely not tight.
oh, that is sure not tight.
Over your computer.
Different types. How many different types of wheel? How do you just type the wheel? There's a food wheel? Oh, I can't anymore.
Oh, holy shot going in. Can twist now.
One's flat, one's
Only for the
it was a team effort. Do we have a flathead
Okay, no, that's what I said after.
The one thing I know how to do.
Okay, no, but what I thought she was gonna do is have the bracket that are like that thing the other way, so that it, like the bottom part sits flat. Yeah, sits flat. So then the green parts actually connect to the red part. So the green part's sitting on top of it.
It still works. Well, it's okay. It's just
It's attached.
This is like what's edited on this one. They're giving me like
Yeah, obviously. I need to. Oh.
You need to get the other cable anyway.
Yeah. HDMI power injector. Oh, because it needs power.
Yeah, it needs power to get the cable.
I have a fiber optic cable.
They do need power. Because you need power. No, they wouldn't. I don't know if they need external power. They might not need external power. Oh no, the active ones do, but the fiber optics might not.
Why are they all different colors?
cool. I just think I get cold. So we just use water. It's actually like
It's pretty thin. It's not like you're trying to like obnoxious people.
oh my god, I don't even bring that up. We have to display the triangle, bro.
Yeah, we're not having to display Pascal.
It displays Pascal triangle only. Oh, yeah, so it's an acceleration thing. So all these values are roughly zero. I'm gonna move it. Oh, actually, just like it is. It's roughly stable. The watch as I
No, I don't know. For that exam, it's just like really easy. So I studied, I'm not doing skiing. I think like, yeah. What do you was not doing? He lied, yeah.
having their there's also ways to go with these kids. Like, I heard like you know more it's very bad. Oh, I'm so
Oh yeah.
Where it's like did you like 8 options or it's like the code actually doesn't work.
Yeah.
I can know if it won't work if I click, you know, output.
That's why I don't like the coding paper week. It's just for like you can't
More distraction out, like
Well, you're prepared now.
guys go to the second one.
You just work and just add it to the final.
No, this is an idea I honestly not really sure. What if we just don't go
In your code, you specify the next one. You just
that's like civil rights. So now the second one is good difference. So basically the second one.
What about
I want to slice.
Everyone is good, yeah.
And I want to set up
is there a document showing how to use the gyroscope?
I think there is. And if you like, if you look at this, on the there's like there's one door, and then you have like a whole bunch of pictures of like what part it is. No, it's not possible. I haven't read about it.
I actually use this library yet, but I put it yeah, I haven't. I'm not live. That is also you. We don't have any. That's one thing. It's oh, sorry. Why don't we use all of them one more in? Even if it's not like, yeah, I'm just curious. Then you can use 4 wire guns and oh, sorry, you have to turn it on. No. Oh, okay. I see. Just probably only. You need to like your suspension. 1x1 MPU 6050 and then 1x1. You know what I mean? Have the red, have all the units go in one row. Like you see just now that way, then it's making it it's okay, it's okay.
Time to drive.
We'll fix the wheel configuration. We want to test it. Oh, I see. It might be for the wiring.
Wait,
Use only your banana. Yeah. Okay. I'll be back. Oh my god.
We should put this in the board.
Okay, there was a.
Yeah, I was just gonna say like the original. I uploaded it twice actually.
What if this just works? We just fix it like that. We just have to fix it.
I thought this was a wireless control.
So I think the wire.
Did you put like a delay on it or something?
I think
you want to switch judgment about it? Sure.
like which one's
no way he messed up the most, like,
I think it messed. I think it
I mean, if he put the wrong way, it would rotate and I like to show him. Yeah, so it will still move.
One's a 4-star, one's a 5-con.
Put it back.
Back to the drawing board? Okay. No. I mean,
And we know the motor's working, you guys come on.
How was your hot chocolate event?
that is the power supply with the battery in it. Is it? Is that the power supply with the batteries in it?
We should use this LED. No, absolutely.
There's this.
Batteries are
Can we mount on this?
Well, it was a viable option. Yeah, I think we can get them to something. Or we can just, yeah, like, okay.
Like off of this.
Yeah, off of the little, like, through the little plastic bit of water.
Okay, yeah.
You can probably I just bite. Probably.
Wheel or something like that.
Yeah. Guess what? It doesn't quite reach by a couple feet.
no, it's start kit and you can all of our motors are called oh yeah, I'm thinking sit down. But
Are those on already? I think probably the servo. The servo's gonna be faster and more reliable.
Yeah, I think so.
And it also has
whatever something.
Yeah, let's take
it's 180, yeah, stuff like this. honestly, like they don't care that I hit these. As long as I don't push it.
I don't know, but we get some regular language.
It's like, well, actually, I don't have Instagram. So if you try contacting me there, I will not.
It's definitely easier to solve.
Oh, because like I had the app open, like it did easily. It's just to avoid
Dance, because we changed it.
limit your screen time.
Okay, yeah. I don't know. Oh, because you can move it. But are you like able to? Yeah, I it's like you play the mechanical, let's say, electrical, then you have electrical, let's say, solve your issues. Just don't get the slow down. It's like all one, you know. It's not like
The server. Well, they would care about is being
Yeah, it was like 100. Yeah, 112. So there's no code. Let me. It is that one.
This should be like a
would you prefer education or directly related to the would you question that follows on you could do it the relation between the Paul will probably return back to the past, right? So when those pulses are coming back faster, it'll slow the motor down. Actually, do you just want to unplug the HDMI and we'll grab it after? Unplug the HDMI and we'll grab it after. What? Unplug the HDMI.
All it should do is give you back
the other one.
So
don't put it right there. I will show you. So.
Oh, you want to bring it back that way?
We'll route it separately. Just a step.
I see what you're saying.
Oh, okay. You know, this is great. Yeah, because what it says is that the speed that the shaft rotates at is directly related to the amount of pulses. Yes, I think that'll transport. So then it'll move, like, you can make it so it moves faster and it's further away, right? So like pulses there's less pulses, and then when it gets closer, then it'll automatically slow down itself.
if it's 10 centimeters from the wall, that's supposed to zero.
Yeah, exactly. So I think this would be the best if it's like directly related to speed. This is the step.
Well, it's usually how it is.
I'm thinking though, because there is a manual component to it too. Right, because there's two, right? There's manual and automatic. Are you wanting to try it?
I think it'd be cool to try. Even if it doesn't work, what were the expectations?
Why you said
Once this now, it's gonna be.
I'm worried because mine's public. And so
just have to organize the components in a way where the weight kind of distributes. Or just add stuff in to make it more accurate. Just get a bag of bolts and just put it over the no, because you're talking about like, what if like the weight of like all these components, right? Is the balance, and you have a bag of bolts just throw it in the corner.
That's the point.
I can say, when we ride that train, I work
Yeah, you guys are using traffic crazy. Oh, I don't know. I just all the make sure I did the order. A lot of the problem is
I'm gonna water it.
those are like this.
Come and get some music. Let me know. Text me. Okay. I'll be.
Just arbitrary.
You guys figure out what? Maybe it's like when everything was thrown together, the wires, maybe something. So like teachers trying to put all the issues together.
Teachers wire.
No wire man.
So then basically the move is slackly. It still doesn't. Okay. Unless you can move it. See this kind of move it more towards the back. Away from the main.
I don't think this one's even doing anything right.
That one?
Yeah. It might be too down in the chair.
Thank you so much.
See, that's what
It's just a number change. It's just a. So that means how many more computers right now? How many of those boards do you have? Oh, there you go. Wasted time on this.
What's the well, I'm gonna.
Should we actually ask for later? Where is it? Well, we'll figure it next.
Well, this one, because this one is hard to close.
If one guy just uses the motor, we just because just because there was that problem. That's better. I don't remember, but because they had the ramp, it was. I think the ramp was a wall, right? Like it's a.
When you put something together, you trust the parts are working on it.
Yeah, exactly. I think that's the worst thing about electric. Okay.
Yeah, for electrical, it's particularly difficult with like any of the connections.
And then depending on how they can mount this, we can literally take off the plastic.
gotta fix.
Okay, Alex. So that's
It's looking like,
yeah, I mean, that's we have, but we can get that one.
I think more what I want to do is like.
So it's just so the other motor works.
it's seeming like this board.
Do we have any more of these?
I don't think it's a wire, individually.
Maybe it's got to be. People like Jarvis. Okay, Jarvis. What do you mean?
Maybe, I don't know. Let me ask.
Yeah, humans wrote like quad and quad is coding and stuff. It's like using Siri as Jarvis knows like Jarvis
The final test?
Jarvis.
Here's what's
Jarvis, don't get joke.
I love just asking.
Wait, play my profile. You know what?
You guys get old. Do you guys have any extra, like, you know the small screws for the motors, man?
No.
Yeah, I did. They can't find it. We're fucked, bro.
It's over.
You guys haven't had any extra nuts, screws on the for like small ones?
That's exactly how we feel.
Yeah. Oh, you snoozed the lose. Hate you.
Are you playing games here?
No. I'll keep energy if it's okay.
It's just,
Yeah. Transmission back.
Wire here, so it's right
Try different battery packs. Usually battery packs.
there's a purple yellow.
Trigger is probably
Shortest wires are the ones connected to the
Yeah, okay. It's is it bad? Like, is the lens bad?
love how hard we really want to get to start with. Yeah. But I think I don't need to rule it. No, because I'm not because she gave me a rule and I broke it. No, it's not because this one's not going in my hand. And it's also too the material. The material the polymer and
I think you could like really test right now, but we just like swap one of these. Here, test out this. Start. We swap out the wheel. Yeah. Just to make sure, if it doesn't work, like I'll like give it a call. But that's so weird. What should be happening? Like, are these grounded well? Should we ground them out too?
Well, we don't use that one. It's just magic machine plus four.
I guess just swap them around. If it doesn't work out, I'll take this.
Yeah, but the timing thing.
Maybe it just creates like a high enough. I don't know.
I think we just gotta go with that because if we do it and I was gonna try it, the motors.
Trying to go with that left or that is not.
No, big design is
It's like basically.
We turn 90 degrees to the left.
Yeah, that's the flash. Which we should get like a
It is, then we can
It's basically what you use. You have the ultrasonic
right.
how do you probably use it? Do that?
So if you bounce down.
Oh, you don't do that? No. Yeah, we kind of need the wheel system.
Well, you have to do the calculation. All it does is gives you basically you trigger it high on the trigger pin, and then it gives you a high back on the echo pin when it hears something bad. And you have the data to get there. Exactly. I think, yeah. I think try to use very many libraries, because for one, it takes a long time. And two, stopping blocking libraries.
One thing the guy said
Your functions are blocking, which means that like when that function runs, nothing else can happen. Which is what we're doing with the buzzers.
somewhere in the box. Really? I just saw like both fingers. I would still look at it because like even this kind of process. Yeah, there's so many like connections.
Oh, it's probably the like speed of sound. What's the whole?
Wait, did I V equal V equal possible?
Oh, could it be the unit conversion because it's in seconds?
Okay, so that works. We're getting this working right now.
I'm guessing the way that this would work is that you just take whatever. I mean, like
It would be the because if it's driving towards up the ramp, pitch. That's the idea.
trigger. Huh? Can you like have that?
I've had to detect it. It's either D or P. I was looking at the values.
Yeah.
They're like the bottom of the because your target pitch is 0.
Yeah, you can do a PID. I just remember the PID being kind of
Well, we don't know. Try.
basically it's square, and so like there's a very large where you about is like, oh, I'm not quite down. It's just amazing. How about this? You can just
Why? Don't give them back.
Oh, it's times time. It wasn't even considered.
Sorry, it's me. Oh.
So they don't see it. It's only regular and normal. No.
See, it's one thing.
With that, I was looking for a
No, the meme? Probably Bob's No, that's a meme.
Oh, you might have to just include it because
not H. I make a mock of it. Like when Alvin brings up the engine and like her sister's her sister's boyfriend is like her or
It's like you have all this information to make something that doesn't happen exactly. I'm like, what?
It's definitely good for more people. I appreciate the tasting food now.
It was like a straight line, number one. It was like how you do the mathematics to be able to verify. Make it a straight line.
We got battery power.
Which one?
Start with the one on the top.
That's such a
So red told me it goes to the gold right? One to the controller, another to the other battery, and then another to the other driver mode, and then one to the Arduino board. This tower.
Whatever you say.
And then, oh yeah, the VM moving up there.
This error should be like, please report to this.
I got a an error that says this error should never happen. Just all like JRC
That's great. Which is like the official company. That is
the guy.
That is you know it's bad when you the error says this should never happen. That is actually like when you press the dock. Okay. The first line. Do not use this function once. But I mean, that's not like above these ones that count. Like, only a certain amount of people can work on the same thing at the same time. Like, you do that.
Well, now I guess I just gotta register all the other ones, right? So
Scan it. Scan it.
two. Two.
Okay, I think it's done. You just done.
That's crazy. I know this one we just bought like Lego Ninja.
So compile fabricated, that's awesome. Just need it.
Then you know what we do after we build the Titanic? We break it into parts so each one of us can keep parts of the Titanic. So what we do is we do that. Celsius. Then we just cut straight through it and like super glue all the other stuff together. Like, oh, like what you did. No. I know he was. starting the internet.
Yeah, it's gonna take a bajillion years of trial and error.
I think it's the battery, half of the batteries inside.
Well, the guy replaced batteries.
How are you?
No, the other one.
Like sped. I'm just ignoring the words I've said.
How about this? Turn it off so that when it's back on. Ready? Power off.
You know we're putting it on the front.
Just motors. We need it on the front because you can't spin the servo until you spin anyways. So
Right? It's only how much it moves back and what the motor speed is. But realistically, and then based on
We're not even getting joystick input now.
we just need the perfect motor speed.
oh, I see. We switched the battery. Switch the battery. Switch to the one. Because it was taking input to switch the battery.
Right, but then if that's the case, it's just like
But I thought the signal was like the input was independent of the battery.
Maybe I comments and stuff.
Battery power motor. But now it's not even you have power. You need to have Arduino on. Arduino off right now.
Oh, maybe that
Oh yeah, check your pin.
sure you're reading this. Okay, what's
yeah, I'm saying move the
pull up your computer,
whole car.
go to like the repo.
How many? So okay, now is the
Pull up
power
the codes because you can actually like cross check them. Based on what's in the yeah, I don't know. Making sure.
No, it's not.
Okay. We are also having some phantom issues.
I think it's the main dot.
See, I always felt motivated. You hold stuff so it doesn't hit the board.
One more is not going right now.
Can we connect this one?
We can take a break and we'll get right.
Raymond, are you there? Raymond, are you there? Over.
I don't know. Hello? It all started after we had to go with the C. Maybe we just remove it. They're not using it, right?
Sure, yeah.
And you left enough pizza for that. What's the ETA? Probably 20 minutes, I hope.
Plug it in all the way.
Guys, I'm hungry.
Yeah, that was
But why would that? I'm hungry.
So now we added a third stuff not working. First.
Look, we all need the wires from this car to begin with.
Second, the equipment doesn't work. Third, the person working the equipment doesn't work.
We're all connected now. Everything connected. Motor's up.
What's the fourth one?
Wait, how does that happen?
Yeah.
Well, I don't know if it's that. I was just checked it a couple of times. You guys know where to get the key?
We'll have to figure out how to get other batteries.
Well, maybe because this disconnected. Maybe I can set Let me.
I'll come with you right now.
There's no guys.
Don't even gaslight me, bro. Like,
It should just be
This is teaching us diversity.
wheels to go. Oh well, we had 3 of them. Yeah, that's it.
And also when this whole part ends, it wasn't
Is it?
What's up?
Okay, I think this may be multiple teams or maybe not. That team over there, they have 3 motors working, 3 wheels working, and then when they have the 4th, it overloads it.
Have you tried changing the batteries? New ones?
yeah, you changed the one that was having an issue.
Yeah.
And then we swapped it to the other one like you suggested, and then suddenly kind of all the so it would only take a week until it was connected to a certain battery.
Okay. Which one were you powering? Which one were you powering? When you said there were yeah, so if you power this one, right? There's no input. Yeah, like there is no input, so it couldn't go off, right? So nothing would go. So you would have to.
So we had both batteries.
Oh, you powered both of them? Okay.
Like we swapped them and plugged into the other ones, and then it would only take it from a certain battery.
Really? I think they change out the other one as well. I mean, it would be so bad. It should be 6 volts.
Yeah, I just measured them and it was 5.6.
That's okay. I think this pack is pretty bad. This pack is done for. Okay, so there's a sort of a pretty bad, but I think the Duracell could be more. So I'll just 5.56 is a bit so less. Should be 6 because I just. Yeah, I mean so if this turns out to be our using power on, that means this regulator over here cannot step down the voltage from 6 to 7.5. Yeah. Then it's not getting the necessary voltage to be turned on for successful. So I'll just change it.
I'm gonna tug it out with motor speed. Oh, see that? Guys? I'm missing. Why are we missing a wheel?
What are you guys looking at?
We're working on the design, so we're discussing stuff about the code, but we were just waiting because it was almost done. So
See, yeah, that should be the ideal. So the 2 Duracell batteries are, I think, old that are working because there was a new back I don't know why put in there, but test now. I think all should fall. It should be okay.
Well, we were working on the assembly, and then we gave it back to them to make sure it's working. Making the code.
Like, are you guys
You have to ask who you gave your
Second year.
what are you guys talking?
These are all Mechatronics and also Mechanical.
Is it good now?
Just ask you guys. If you want to lend us your ultrasonic sensor for like 5 seconds,
Yeah, how did you not notice that?
It's okay.
Get more motor, right?
No. Something could be wrong with the wiring, but battery is not an issue now. Yeah. Well, you got one issue down, like he's resolved, I think. fix your wiring, it's still a bit messy, I would say. Why don't you just mount motors on the board and just place it at a height so that it doesn't move around?
Well, look at the map.
We're just like trying.
I know, but it seems like look at fixing all of this is hard.
I'll do it.
We're just trying to get it to work first. Just make sure you have the column down if you don't have that.
No, like, you have time to.
Yeah, I see.
Take time to slow. You got another method at any time. It's like, oh yeah, it's like between. It looks so bad. When you just draw blocks. Right. So it's like you have I guess far out is we have to find a circuit. Having just a moment.
Check your board. I will just stretch it. I think that's good.
The code that we're using for start codes is
It's my blanket eventually. Should be safe.
You might want to also play around with the code, okay? Don't take it like this by word for word. One more thing that you could do is sort of having speed
Gray is
if you put those backwards, then it would be at the maximum speed. I really want that. It makes it easier.
They wanted to slow down as the distance closer.
It'll either put 200.
If it's manual, sure.
Just make it stop.
If you get, yeah, probably you should just if it's quite low to that's what we want about 200, just throw it out.
those big ones do look cool.
I would say like just build it out first. So use it. Straight up.
So now
Have it everything
are those unusable?
So I think it's maybe bouncing.
The wiring could still be an issue. That's what's going on.
Oh, I bet you. Wait, is that actually true?
Yeah, it's going like that way. Yeah, it's not even bad.
So actually, you know what?
So it's like some of
Well,
this
2.3. That's
Like rough.
why don't we lock it? Just carry my computer.
I would say just put numbers on and start chasing them. Just do it, but you can do it
Bring it all. Yeah, that we can put it back together. Genuinely feel like
Oh my goodness. Oh great heavens. Oh great heavens. Oh. Oh great heavens. Ow, my finger. What is on? What? O-ring failure.
Yeah, that's what I was saying, right? Because I don't know the way he's so into it.
she presented as a service does not mean that's what she did.
Also, this is not a full project.
Pizza's here.
So I think and they probably kind of just like 20th. They got two pieces and it's like a piece. This might kind of range to so what do you want the range? The range is 50 cents per gram. I think it should probably be like a meter even. Yeah. Yeah, because the thing is, like, I was looking at like the ultrasound stuff, but I can't do it unless I can get up. I need the Arduino. Yeah, it just passes. It literally swaps the R's out with this one. But I mean, there's one more.
Do you still have your board one by chance?
I don't I think that's just like
as long as you keep
right. That's not like, yeah, I don't think it's the same. Oh, keep this one as a kid. You were only do so much at one time. Yeah, that's like, yeah, because you were
Also look at like other ways. Because like if ultrasound doesn't work, we also have other sensors.
what other sensors?
Yeah, that's a big. The propeller to drive it.
Yeah, just I think you guys could just look at like using other sensors like well, because there is a chance of ultrasound. Especially if like in the end it's gonna be fun. You just find out like what other
Didn't you say like as long as like what he said? Like as long as you have it on the screen control of the thing, then I can slow down.
Yeah, that's the end.
But it depends on what you guys are doing. Like, you guys are just keeping it so we can do speed control, or you doing it maximum? Yeah, based on the ultrasound, you want the speed control. But the thing is, will the joystick work with that? So you want me to change it to a meter? Try again. Just so
like it's a little messy, yes, but
yeah, it probably is.
can't really simple. We can't simple.
One thing though, is that if we're using the step motor, if we're using the step motor to do it, then it wouldn't even be there. So it did my yeah, because what I was thinking is if we're doing that phone thing, you have to use the step motor for the one to control that.
Hello, can you just get a quick show of hands who is fasting today, just so we can save some food for you guys? Is anybody fasting? 1, 2, 3, just 3? Going once, twice. Alright, 3 people. Okay, thank you.
I don't think it needs to go. It's because he was looking. He was like, yeah, or it's like, I think it's great. Yeah, okay, that's not something. It's because, no, what I'm talking about is that. What are you going to do on it? Just something. I don't know how much that's because the step motor adjusts the speed itself.
We'd have to
All the way back in grade 800 digits, but then I was able to guess 3 more digits in the competition. Oh yeah, sorry, Steve. Why if I just start from scratch and look in?
I think it's coming down, right?
I think right here.
that's I think smarter than that is that battery almost turns out to be how the work done together. But I don't think it's that complex. That's why I say like it has to be that's why are you doing because I spoke to the guy who did it fasting and he counted it as fasting. How do you make it? Oh yeah.
And then it drives still. So it like stands left, right, to the center.
Are you okay? Are you done?
I like that. So so what I think you can do is if you place it in the center, obviously it starts, right? And so the first thing it does is it drives forward. And it drives forward like not a certain say or some set distance right? And then scans left, scans right, figures out the open path, and then it will set the sensor back to forwards, and then scan like right or like the other thing you do keep it in like there is that diagonal.
But that's okay.
Well, I was just thinking like if you have it, yeah, because I think what you're gonna want to do is, or at least what I was thinking.
Alright, hello everyone. Food is finally here. We brought some Costco pizza, so go get pizza. Yeah, and after you guys get pizza, we're going to start our next presentation by Dr. Stephen Dudson.
And my mother having a really fun movie.
No,
I'll be honest. Huh?
We're gonna do schoolwork, man. Huh? We're gonna do schoolwork.
Yeah. I do think so too. I'm not really feeling this like.
Better. Maybe like something.
Yeah.
So we've worn this shirt like 3 times, but this is the first time I've read it. It's great.
How are you feeling about this project?
We got 3 out of 4 wheels.
Yeah, that's the thing. That was like for our thing. It wasn't working. The same thing. Because I was like, you can't really do any of the other stuff until you get like the driving, working.
Put more batteries on. That's what we did last year. We had the 2 AA battery packs plus the 9 volt for the Arduino.
You're out of there.
Same thing.
I know when our 4th wheel wasn't working, he was like, "Oh, just replace the batteries."
What is this? I kind of felt bad.
I don't think it's a battery issue.
Yeah.
I did. I felt bad.
I know. There's solutions for that.
It's easy.
Kind of like, right. Talk to Luke, where he said he was laughing, bro.
Dude, I finished in 4 minutes and 3?
We got it. Oh, okay.
Yeah, dude, I was fucking. I just wanted to say that because I saw it as well. Dude, I pre-gamed at the uni last night. And then I kept all my stuff here. And then I saw you and I wanted to say hi.
Pokemon just you're not participating? What? No, not you. Huh? Why not?
Where's that?
Oh, you liar.
Yeah. Oh, I didn't realize like I just she was just like, oh my god.
There's also an engine night. Find something else.
Yeah, come say hi and visit your project. For the money.
Way fucking easier than you guys did, by the way. I took your guys' exam before. Yeah, I know. I took an extra. It was like all the questions were like copy and paste from the assignments and my return. It was like it was the weirdest thing, but I thought it was easy. But so that's and then so we finished glue fest. So I got drunk at the university in the brain club.
Accidentally, like the variable is T, right? We keep switching from X and T. So for mine dimensions,
One of the densest crowds I've ever been in.
not solving for the solutions. I had most of them in T. For one variable, X and dimensions. So it's the same solution because it was like negative. We're gonna need this negative. So I put negative.
I didn't show for like 3 hours and just do some work. But no afters tonight.
It's like identical.
No afters tonight. Because I went out last week as well for 2 days straight. Oh my guys, my marks are really low. I'm really suffering. But I'm having such a great time. But I saw you guys ain't no way I'm gonna walk by and not say hi. Well, so what are you guys doing anyways?
Yeah, it's except a little challenge. Yeah.
Are you in your own code? Fuck. Can I get a little? Otherwise, no, Quinn, we actually just don't have it on. Right now, it's
Is there a
just so
bonus?
powerful.
Is there a bonus like if you did 3 fights, it's like 5?
No.
Oh!
Actually, no, we don't. We're just gonna test it with those. So, just like, you're like my daughter, the cat's like, I'm sorry. Oh, leave.
Hello? All right, okay, we're gonna start with our next presentation from Dr. Knudsen, so please give him a warm welcome.
It's not like you guys don't know me.
It reminds me of being in Inch 160. So a lot of you saw me there, or maybe saw me, maybe hadn't even as your thought. All right, so let's get everything.
Especially on the weekend, because it's also so busy.
Oh, yeah, good. So first thing, this is going to be really awkward for all of you Mechatronics students. Who would like the equivalent of a Pico? Raspberry Pi Pico. Yeah, yeah. All the people that don't already have one, I have free ones to give away so you can possibly follow along in the lecture. If you have extras, then we'll invite the Mechatronics students. So anybody want Picos? Process, we'll come and get them. Like, don't be shy. Done your pizzas, come and get them. So this is, yeah, you get a cable and a pico. It's like feeding seals or something, right? Okay. Worker at the side. what I want to do is this is another, like the Raspberry Pi Pico is based on the RP2040 processor. So this is another kind of Pico. It's right, based on the same processor, just a slightly different form factor. And what we're going to do is we're going to walk through how to set it up so you can play along if you want, a little bit of a demo. But we're also going to look at a really unique peripheral that's inside this processor that I haven't seen before. So everybody in Mechatronics is going to get to see this in over a year from now when you take ECE 315, because we're going to be using this same peripheral. But it's really powerful. It does a lot of really cool stuff. So make sure I'm turned on. Not working. Oh, there we go. Yeah, so I'll post all of this stuff up on my GitHub. There's lots of other things there, including last year's Albertaloop workshop. So very similar, a little different. So yeah, we're using this small board. It's RP2040, but it's the same processor as in the Pico or the Pico W. And then there's innumerable knockoffs. The actual one that I handed up is actually a knockoff, but it works just fine. So what is a Pico? Most everybody's seen them here, so I'm going to go through this pretty quickly. But it's a really nice processor that Raspberry Pi developed that basically is a dual-core Cortex M0, so it's meant for embedded. So it's for robotics, things like this that you're doing today. And it's got a whole pile of different peripherals that have different interfaces, for example, SPI and I2C, UART. It's got a built-in ADC and a bunch of PWM channels, which are good for powering robotics, for powering motors, applying different kinds of, or different levels of power. It has floating point libraries on chip, and we'll see at the very end here if we get there. There's sort of the good thing and the bad thing about these libraries. So this chip doesn't have a floating point unit. It works mostly or works entirely in integer arithmetic, but it has software that will do floating point computations for you. It just makes it quite a bit slower than the newer version that Raspberry Pi has put out, which is the RP2350. It has a floating point unit, so it's quite a bit faster and a little bit more flexible, and about the same cost. So this was the very first version that came out. The people in Mechatronics know that we're trying to standardize using this processor, so you're going to see it a lot through your whole program. So that's just the Pico 2W, so it's got some extra things to it, but basically the main difference is it's slightly different architecture. And it actually, you can boot into two different processors, ARM or a RISC-V processor, which I actually haven't tried, but it's kind of fun. So they're very inexpensive. This is why we like them. For the Pico 2, it's still around $11 for the wireless version, versus an Arduino, which is quite a bit more, $25 if you're lucky. If you're buying real Arduinos, why would you? And if you can buy one of these, double why would you? Because this is like 30 to 40 times faster than an Arduino, with more RAM and more storage and more of everything and all the same I/O. So it's really, I would say Arduinos are great when you're in grade school. By this time you should be looking at something more serious like a Pico or something else. A lot of the Mechatronics students will recognize this. This is where we're using the Pico this year, is on your robotics project in Mechatronics 260. So this was a board that was designed by a computer engineering graduate from a couple of years ago. She came and helped me design this and put it all together so that it actually works. And for you guys, surprisingly, it does actually work. It's the first time she'd ever done anything like this, and it all just worked the first time. So pretty cool. So this is what I just handed out. It is compatible with the main Raspberry Pi Pico SDK for C and C++. So you can program it like the Pico in Python. You can even put Rust, or use Rust to develop programs for it. I've done that before as part of a different course. But today we're going to basically concentrate on the C and C++ SDK and take a look and see how that works. So the first thing we're going to do is how do you set up the program with Pico? So all of this stuff is going to be available. You can download the lecture notes and stuff like this. It comes from lots of other tutorials that are similar. We're going to use VS Code and set that up. And then we're going to look at how we can use this internal peripheral, which I'll explain about, and to give it a unique sort of ability to do stuff. We're going to use it to actually power, I mistyped that. We're going to use it to actually power an RGB LED, but you can use it for all kinds of other things, including powering old CRT. So to set things up, everybody probably is running VS Code, so the only thing you really need to do is download the Raspberry Pi Pico extension and install it. Right? So if you wanted to play along, you could do that, but it's a little awkward maybe when you're eating pizza. And then the other steps, if you're on Mac, you have to actually tell Xcode to install the command line utilities. That's not a big deal. And the same sort of thing in Linux, just slightly more involved. But when you install Build Essentials, it brings down the compilers and everything else you're going to need to run sort of program picos on your machine. So once you've done that, then you basically access the pico icon, which is the little icon down here. Looks like a pico chip, and it brings up a menu of things you can select from. So we would start, of course, I didn't know where I was lecturing, so this turned out terribly. That's supposed to be sort of a red box around select new project from example. So the project we're going to select, normally everybody selects blink, right? To blink an LED. That's, if you can get that working, then you're pretty happy. It means you can do lots of other things with your embedded processor. We're going to choose a different example called PIO WS2812. So WS2812 it's also known as a NeoPixel if you buy stuff from Adafruit, but it's basically an RGB LED, and it's got a little teeny computer inside it that it uses to basically control the illumination or the intensity of the R, G, and B LEDs, right? So you've got 3 colors. And it can be daisy chained together, so there's only 4 connections. You can't see the other 2, but there's 2 connectors here. So there's power, ground, data in, and data out, which means you can basically string them together, string the pixels, these NeoPixels or the 2812s, you can string them together in a serial connection and basically write bits to them as a daisy chain and have a chain of things. You can have a strip of LEDs. This is how those LED strips work that are RGB. So it's a very simple programming interface. You basically just push bits into it. Since there are 3 LEDs here, each of them takes 8 bits, you have to put 24 bits in to get the LEDs to all light up the way you want to. And if you're doing, say, 100 of these all strung together, you'd have to do 24 times 100, so 2,400 bits that you shift into them. So this is important because this is what we're going to use the PIO, the programmable I/O, to shift bits into this LED. We're going to use the one that's that's installed on the actual Pico. So there's one on the Pico, which we could use, and in this case on the RP2040 Zero, the one I just handed out, it's the same device, it's just a different pin. So we'll have to do a little bit of changes to make that work. So again, I did not know we were lecturing here, so this is okay. You can sort of see this. When you ask for a new example project, this dialog comes up, and so you would choose the actual project example you want, the board type, which is a Pico. There are other board types that are there. So the Pico 2 is there, for example. Then you can't read it here, but the location where you want that project to live. And then at the very bottom, there's a create button. You just leave the default debugger. We're not using the debugger. You could, but we're not going to use that today because we haven't got a probe to actually talk to our target. So then you click create, and you get a project, just like you'd expect. And, oh, this is so terrible. I am so sorry that I did, well, I don't think we can turn off can we turn off the lights near the front here?
That's what I'm
Should be right up. Yeah. Yeah, let's try and do that. I'll make it a little bit brighter. Otherwise, it's going to be hard to talk to
Yep, that was it.
That's better. Okay, and then I don't mean for you to read all this in detail. There's no way. But basically, what you get for the example, for the example code is you look at the C code, and it looks relatively straightforward. The stuff I'm showing right now is just definitions. How many LEDs do we have? So this is set up for a generic LED strip. So it has number of pixels. In other words, number of LEDs is set to 150. And then the pin is set to pin 2, right? So we care about that because we have to change that for this example, so it'll run on that, on the RP2040 Zero that I handed out. But at the very bottom, after you've installed that extension, you get this very nice, the usual compile and run options you have at the bottom. So this tutorial is meant for people who haven't actually used this very much. But yeah, you get to just compile or run. So it will just run. Oh, a little bit of XKCD. Everybody knows me as a professor, knows I like to have XKCD, not examples, just cartoons. If nothing else, you might enjoy the cartoon, if the lecture sucks, right? So this year, of course, now that I'm doing a lot and allowing students to use AIs in the courses, this comic's slightly more relevant than it was before for me. All right. So we have a different board, as I was saying. So we're going to have to change some things so we can actually use that 2812 RGB that's on the Zero. So we take a look here at our pinout, the usual thing. You go and check it out, and there's a nice little box here that tells us GPIO 16 is the one that's connected to the RGB LED. So that RGB LED is that little white guy right in between the 2 buttons. This board actually is a little bit nicer than the normal Pico because they give you a reset button. If you want to put the Pico to make it programmable, you usually have to hold down boot and then plug it in, give it power. They actually put a reset button so you can leave it plugged in and put it into boot selector mode, which is very convenient. So I like that. I don't know why Raspberry Pi didn't do that. It seems so sensible. Okay, so we know what we're going to change. We're going to change the number of pixels, because we only have one, like one RGB device. So we change that in our source code, our WS12, our 2812.c, and then we change the pin number from 2 to 16. And I just commented out the other stuff here. I didn't care about being nice and neat and tidy. So now we've got that set up correctly, we just compile it. And another XKCD, a classic one. It doesn't take very long to compile. The very first time it does, if you've just installed this and the extension, it's going to download all the libraries and everything you need. But after that, it's pretty quick. So, to actually get it to program, you're going to have to put it into boot select mode. So for the RP2040 and for the Pico, it's the same thing. You basically have to press boot and then plug it in, or press reset, and then release boot, and it puts it in the boot selector mode. And what happens is it shows up as a memory device on your computer. And that's a programming paradigm. So now you can compile stuff and you just drag and drop the image onto that memory device and it will program. VS Code knows that, in a sense. That's exactly what it's doing. When you say run, it basically copies the file to the target. So if you haven't put it into boot select mode, VS Code will warn you and say, no, sorry, I can't find anything to program. So that's the only sort of wrinkle. You have to put it in this certain mode to be able to program it, but otherwise it's pretty straightforward. So what are we actually doing in the program? So I compiled all of that, and I did get it to run. So we'll see if we can show you it running. I've got a very nice long cord. And of course, it's just one little LED. Oh, that's not going to work at all. This might work. Yeah, there we go. So all it is, that program basically walks through a whole pile of different patterns. You can barely see it. But that RGB LED is segmented to all different colors, different patterns. It's got umpteen different ones it's doing. And how is it doing it? It has to transfer the bits for each of the RGB LEDs, so 24 bits at a time to get a different color. So now it's just flashing. And so it's going to write them through the serial line, and it's going to write them through this programmable I/O engine. So that's just a kind of illustration that I've got here, showing us we've got our main program here that's going to basically fill whatever pixel values we want into a FIFO, a first in, first out shift register. So for those of you in Mechatronics who are learning about registers, this is a shift register. So it's a serial in, or could be, it's a parallel in, and it's a serial out shift register. So it's going to be associated with a certain pin on the Pico, or the RP2040. And then we have a state machine running. And so again, we've learned about those things in Mechatronics 210. So this state machine is a very simple device, or a very simple peripheral that can do certain instructions, but it does them very quickly, much more quickly than a general purpose processor would do that. So we'll look at more of these details, but this is what's actually happening when it's running that program on the RP2040. So what does that look like? So basically what we have is a main program, and this one actually shows up a little more clearly. That's nice. So we have, the first thing we do is we create a PIO instance. So we basically set up the PIO, and I'll show you what they look like. You can think of it just as a subroutine. So we're going to initialize this subroutine with a special program here we've called WS2812 program. We're going to pass that in as an address to this, plus some other stuff, which PIO device, some other things that don't really matter to us right now. And then we're going to initialize that. And this sets up the speed that it runs at, for example, and which PIO engine we're using. And then for the rest of the time here, in the main program, we just go round and round this loop forever, where we've got a table called a pattern table. And this pattern table is actually a table of function pointers. So there are separate functions for each of the patterns of LED lights that we want to show, which is just a clever way of doing programming. I do not think in Mechatronics 294 you've seen function pointers. I'm not sure you're going to see function pointers. But you can think of a function pointer as a kind of program that you can pass to another function. And you can say, hey, invoke this function for me. That means that at runtime you can change which functions are being passed in to the same program. So we're passing into our PIO program, we are passing a function, or we're passing a function that will specify the RGB values. So again, it's a little bit complicated, but it's a really elegant way of doing things. So this runs forever. It actually, I don't think it does run out. It doesn't ever leave this loop, but a good programmer puts down a cleanup routine at the very bottom. So this is what the PIO looks like in terms of programming it. It has its own assembly language. So it's a simple state machine with a very small set of assembly instructions. So again, those people in Mechatronics 210, I just introduced assembly language a couple lectures ago, and we're looking at the RP2040, and it has a relatively large assembly language compared to this one, but this has a very, very simple one. And it has some basic directives here, but the programming happens between these two directives, wrap target, and basically think of it as end wrap. So this is where the program is for that state machine. It's a very simple little program. It has a label called bit loop, and then it has an assembler language instruction called out. Now all that out does is take whatever's in this register X, and it says how many bits. It shifts out that many bits out to GPIO. And so it just goes around and around and does this in a loop. And basically, when it shifts a bit out of X, it shifts in a 0 bit. So as soon as X equals all zeros, so it says here jump not X. So if X has got a 1 in it, it's not going to jump. But as soon as X is all zeros, it's going to stop doing this loop. It's going to stop doing this jump around. So there's a very, very simple loop, and it just simply moves out 32 bits. And those 32 bits go into our RGB LED. So this is what it looks like when this is the rest of it. So when you assemble this program, you have this initialization function that's sort of pre-written for you. So we don't need to worry too much about what it does here. But there's a separate assembly language program that assembles this particular kind of program. So it's separate from the main compiler that you would use for C and C++. It comes with the SDK, and you call it luckily. VS Code and the extension that we installed already knows about it, so it knows to call it and basically not compile it, but assemble it into hard code. So again, this is now back to what the PIO looks like, programmable interface. So it's a hardware peripheral that sits inside the chip, and it has all these building blocks. So it has 4 different state machines, and these state machines basically take those instructions, the assembly language instructions, and do things. They move memory around, they clock bits out to a buffer or bits in, that kind of thing. So there's basically a really nice little peripheral that runs all by itself. The key thing here is it runs independent of the CPU. So you can have it doing things for you, and your CPU can be busy doing something else. So it's a very, very powerful idea to hand off things to a peripheral. You could even put the CPU to sleep and save a lot of electrical power, which is very, very interesting. So it has all these first in, first out buffers, so they're kinds of shift registers, that each state machine has one that comes in and one that goes out, and it has connection to a bus here that maps to the GPIO pins, so any of the GPIO pins from the RP2040 are available. It has a very short instruction memory here. You can store 32 instructions, which you might think is very limiting, but you can keep adding instruction into it as it runs through them, right? So you can keep changing that little program. And usually that small program is all you need, because you're doing simple things with a PIO. It's just there to offload doing simple things that take time from the CPU. This is how it fits in the overall architecture. So the overall architecture for the RP2040 has 2 processors, Core 1 and Core 2, or Core 0 and Core 1. We have a direct memory access engine, which is good for moving stuff around independent of the CPUs. Again, offloads, moving things in memory. You'll learn about that in ECE 315. Some of these slides actually come from ECE 315. And then we've got all these different peripherals. So we've got a bunch of SRAM. We have our PIO engines here attached to another specialized bus that is meant for high-speed operation. That's the other thing too. The PIO, for example, I didn't put it up here, they can move data at about 100 megabytes per second, which is crazy fast. Because the CPU is running at 133 megahertz, so you think, oh, well, maybe the upper limit would be something like 133 megabits per second, right? 1 bit per cycle. But you can do things with the PIOs like have basically multiple pins in parallel outputting data. So it is really efficient. So it's up there with USB speeds in terms of what it can do. Not USB, 480 bytes per second, but pretty good. No, probably it does do 480 bits per second. So yeah, it's very comparable to that. So very, very flexible. And then we have all our other peripherals here that are on a slightly slower bus. things like our I2C or SPI interfaces, analog to digital conversion, pulse width modulation, other things. All these things are also accessible to the PIOs through these bus structures. So it's very, very interesting. You'd use the PIO, for example, to take samples that are coming in from an analog signal through your ADC and deposit those samples back into SRAM without ever having to have the CPU be involved. So you can imagine that being quite useful if you've got something that you're monitoring, some pressure system, some kind of a sensor system that needs checking periodically, and you don't want to wake up the CPU. You can just basically have that data being sampled by the ADC, being put into memory until it's ready to be processed, and then wake up the CPU to do that. So pretty flexible. This is a little different picture, same idea though. We've got two PIOs that are part of our RP2040. And so they basically belong in the system bus and can be accessed by the CPU, but other peripherals as well. And what can it do? It can do all kinds of things here. I have no idea why anybody would be interested in this day and age in 8080 or 6800 parallel buses. So the 6800 was the processor I learned to program when I was here 46 years ago. I guess I started to learn to program 44 years ago, right? So it's ancient. Why is it still around? I don't know. But these other things, yes, they are very relevant, right? So I2C, inter-IC communications protocol, very common for peripherals. Serial I/O, this is the debugging input. This is for SPI, so serial peripheral interface, all kinds of stuff. But they also mentioned, and they mentioned this in the manual, that you can use DPI or VGA. You can actually run a monitor using your Pico, which is super cool. So I'll show you that at the very, very end, but it's something quite unusual. So yeah, interesting. So this is some of the details of the PIOs. So 32-bit shift registers, 32-bit scratch registers. So something you can do some intermediate calculations on or can store a temporary value. It's got 4 FIFOs in each direction that can be reconfigured as a much deeper FIFO in one direction if you want. So first in, first out is what FIFO stands for. So it's a kind of shift register. We have clock dividers so that you can have it running on its own clock, so its own speed, which makes sense. If you're talking to an interface like I2C, which runs at anywhere up to 100 kilohertz, kilosamples per second, that's a lot slower than the main system clock. You're going to have to divide down that main system clock to get the right clock rate for that interface, for that serial peripheral protocol. And we can, like I said, we can map to any GPIOs we want. You can actually use DMA with it. There's a different example I have where we're basically using DMA to transfer stuff directly to the PIO. And then you have interrupts. So when something finishes, you can have it interrupt the main processor and say, I've done my work, what do you want me to do next? Or it can interrupt the DMA engine and ask for more data. So really quite flexible. So this is what it looks like from a programmer's perspective. You've got an output, you've got a transmit FIFO that goes into a shift register. You've got a shift register that can go out to a receive FIFO. These things can be read by the main processor or DMA. You've got a program counter that is walking through the program that's stored in the instruction memory for the PIO. That makes some sense. You have some control logic, control things. We have our clock divider, and then we have our scratch register and our access to GPO. So this is all sort of the programmer's perspective of that device. You don't have to worry about what it looks like physically. You just have to know how to talk to it. And these are the instructions. You don't need to worry about reading this too much, but just look, there's just this many instructions do all kinds of interesting things. Jump helps you go and do loops. It'll let you jump from one instruction to another. So if you want to do a loop, we've already looked at that, is you can compare with something, and then depending on what the value of that comparison is, you can jump to another location in the program. Waiting, you can wait for different things to happen. So this you can imagine being useful if you're doing some kind of an interface protocol where you're talking to something and it might be slower than the actual Pico. So you wait for it to respond. Input, these in and out, this is for shifting through the shift registers, push and pull. These are all interesting instructions. Set makes some sense. You're setting values in a register. You're setting something on the I/O pins. So very simple instruction set, very easy to use, but also very powerful in terms of what you can do with it. So for example, this slide works better. If we want to make a square wave over 4 cycles, it's a very short program. We declare a program name. This is just a directive. We set the pin directions. So we're going to set the pins that we want to use to output to this instruction. You can read this instruction, but this is what it does. This is the target. This is what the value is that it's going to set. And then we have a loop where we're just going to go around forever and ever. And we have basically, we set some pins to the value 1. And then this thing in the square brackets is just an instruction to say, wait one extra cycle after you've done this. And there's a reason for that, because we want it to be something that's 4 cycles total. So we want half the time we want the output signal to be high, and half the time we want it to be low. So for 2 cycles high, for 2 cycles low. So if we didn't do this, this is just 1 cycle. The next thing we do, the next instruction is set it to low. So it would only have 1 cycle here, it goes to low, it's set to here 0, and then this jump instruction takes 1 more cycle. So these 2 instructions take 2 cycles, and when it jumps to the beginning here, it's going to jump to that. So this is why this one has an extra delay here of 1 cycle. That's a lot of detail. You don't have to know it necessarily, but it is part of the language and how you can set things up. So basically, this will take and run a square wave out of a 1 GPIO pin at whatever rate we decide to set the state machine at. That's something we program outside of that. I think I've talked mostly about all of this. This is just, if you wanted to set the PIO's instruction memory, this is how you would do that from the CPU. You have basically some set of instructions that you've set up from before that maybe you've compiled or assembled, and then you want to program the PIO memory. You've got a pointer to the PIO engine, and it has this data structure called instruction memory. And so you just basically are copying bytes into it to set up the instruction. So very, very simple interface to program it, to get it running. This is the idea of the output shift register. I'm not going to go into a lot of detail here, but basically you fill up the FIFO, and then it automatically is clocked out to whatever pin you've connected things to. The same thing for the input. Whatever pins you've got connected to, you automatically clock whatever the value is into this, and then you can push that into the FIFO. So once you've decided you've got something legitimate, you can push it to the FIFO, and it's going to go automatically to your system, automatically to the CPU. So this is the demo. This is the really fun thing where somebody set up, in the background here, we've got a computer monitor. It's a little bit hard to see, but the person is calculating and displaying a Mandelbrot set, which is a really computationally intensive, fractal. It's a very famous fractal system that looks the same at all scales. So has anybody ever played with Mandelbrot sets here? Anybody have any idea what I'm talking about? So the thing about a fractal entity is it looks the same at all scales. So you can imagine this image here, which looks like sort of a big dot, big black dot, and one large dot and a much larger dot. If you zoomed in at the periphery, there's infinite number of these things are embedded on the edges, right? It doesn't matter the resolution. It just goes forever. So it's a very high intensity, computationally intense thing. It does a recursion to calculate each pixel. So it takes a long time. But he's doing that. He's just using it to illustrate. But what he's using here is the Pico and that PIO engine to output all the necessary signals to control a VGA monitor and in real time. So this would have been a box, like when VGA first came out, it would have been a box like this big full of electronics, right? Now it's just a chip that's smaller than your little fingernail doing all that work. Super cool. The last thing I wanted to show you, and some people have already been playing with this, is Walkwee. Walkwee is a really cool site. If you haven't checked it out, it's probably the one thing to take away from this tutorial or this session is Walkwee. It's a great place to go and emulate different processors, and you can connect them to real devices. And if that device doesn't connect, they have an API for creating a custom device. So you can recreate things you can get from a data sheet, like an ADC or a DAC or something like that, another kind of sensor. You can recreate your own sensor in Walkwee. So what is Walkwee? Basically, it's a nice electronics simulator, and you can run code in conjunction with the actual electronics. That's what makes it really, really fun. And you can do things with Arduinos and ESP32s and STMs and Picos. So these are some of the examples that are around. So a 7-segment counter using MicroPython, so it supports Python and C and C++ for languages. It also supports assembly language, and it supports the PIO assembly language, which is super cool. So these are some of the examples, a little bit hard to see here for Pico, so you can go and play with some of these. You can program your own Pico for doing that. People have already taken my advice, for example, when they're trying to program it for something, instead of programming the real physical device, they first test it out on Walkwee, because it's really simple to do, and it gives you decent results. So here's a simple example. Again, this is very much like what we're doing here today, except this is using DMA to control an LED. So this is just some source code that I've written to illustrate using DMA, but we also have a PIO program that we're using. So we're connecting DMA, direct memory access, to move the data directly into into the PIO, which then controls this LED, and basically it's using pulse width modulation to make it lighter or not, or lighter and brighter. I'm not sure that'll show up. I do have, I think that's the last thing I want to show. Yeah, but I do have, I should have it running. Is that showing up? Oh yeah, good. So that shows up. So this is Walkme, that same program. Make that smaller. And so we started. It will run. It's kind of hard to see. Yeah, there you can see it sort of goes dark, and then it's getting brighter and brighter. So all it's doing is it's writing pulse width modulation. So it's writing, a certain duty cycle of energy to that LED to make it brighter and dimmer. And it's doing that all with DMA. So basically, when this runs, the CPUs aren't involved at all. It's the PIO and the DMA engine are doing all the work, freeing the CPUs to do something else, which is very, very cool. I think that's it for today. So thanks for listening, and hopefully those of you that got the little RP2040 zeros find some use for them. Any questions? You're very quiet. Probably having the post-pizza sleep that you need, right? Good, okay, thanks.
Yeah, something was loose. Something like that. It just needs to be flat, actually. So I think putting it on that
Pick it up. Turn yet? Okay. No, not yet. Okay, can we like turn it off? Is that max speed?
I didn't add that.
It can be pretty quick. I'm actually not sure where the little bracket is.
Hello, can I feed over?
I think Alex.
You know what?
Guys, new game plan. No, it's we don't need to miss. Oh, we're gonna move the whole base around our game.
That's exactly what go buy a
Okay, so I fixed. In the end, I think it's like why don't we okay, the wire right. Like honestly, it didn't make sense. So that's good. Then we tried to cool the wire a bit. Now they're adding so that's good. And then we can start chips like this.
That's a. It's about yeah, you're cold. Like you're looking through yeah, that's. Yeah.
That'd be pretty cool.
This is the final product here.
If you put the wheels
They're I can help you.
So I guess you need to do it slide like
I don't think
if you can get two
we
can get the wheels.
Because I think we can do. I don't think I would have.
But for room selection, click the button to change the program to run.
Yeah, we do something like that. We just leave it in bonus.
I think that'd be good.
And then I think that tomorrow we just it's just like this is let's try once. How's it going? Yeah, someone
vegetable oil salt. Over.
How long do you squeeze it?
Check our name over.
Because then you don't have to do these things. You just screw it in the I would say it's good. I would worry about it. We went over so it's in there.
Yeah, but we got you. Come to you.
Mission debrief on the pizza situation. Over.
Chips, bro.
We have 2 prices for the general public, and for us we have 4. How do you turn down the wall? Over. Over. You? Look, this is really
Can't lie, bro. My comms are better than this. They don't have that radiant. If you really want to, that's what he said though. Lifestyle competition, bro.
message was not received. Over. You headed to sexy motherfucker. Over. Over.
But no, he won't because it's like my hand up. We actually put it
Over. Having sex. Over.
I guess you're a big fan.
Substantial. Over. Dave. Over. Over. Nothing going out. Over. We have 4 chicken flying request. Ramen value before 12 volt power source. Oh my god, yeah.
But so we can interact with it. I think it's probably.
That's why John. That's why one is to tell us. So when he's like feeling like down about it, one is to like make sure he it's like when you're close to inflated, right? Remind that you're rewiring to it's a one. Okay, I'll send you my
So I'm not paying attention because my friends were saying the word running back, and my friends would say it's the watch too at the same time that you were saying it's the watch, and I was like,
it's basically a watch has two sections. Like one when you're not, you're, I guess like mentally you're in the gutter, right? Just like appreciate yourself more. And otherwise like it's too piled with points. It sets the actual assignment. So there's the highs and the lows, right? There's I think that's the part specifically. You can't be working hard when you end up running at two.
No, I think what we're doing is the time is basically like working for the entire software is they have two different the two distance intervals, right? And so basically what you do is if you have because they have into the line, making sure they're missing. And so what they would do is they have the two distance intervals and you basically drive over
He said one of the motors has been.
and then if there's nothing to the left and something forward, you know to go left, right? And if there's something on both sides, then you turn 90 degrees forward and test again. And that's why you so so in that case you can always turn it right. Yeah. And like for example on the left. I think they're moving in the opposite direction.
When did you swap wires?
Yeah.
Because it was a practice.
Don't worry, it's probably He's not gonna move. He's not gonna move. You guys want some literally random
No, the clicking has begun.
I know, I was gonna say, it's so torturous. This is torturous. Why did you give him that? What kind of dream are you?
I can prove it. You also get one Steve.
Depending what time you're done. Why? Oh.
Just
Just so that we're not like.
It does.
Yeah, but they're on TV. I keep saying.
Everyone, you're ready for competition, please? Oh, we're a watercolor.
Yeah, we're ready for
It's magnetized. Get apart. That's good. We're driving.
Turn all the way around. Right?
Is it
That was also ironic.
Is it kind of like when Cash says I'm not gay? It's like too true, or like, you know, it's two truths and a lie, but it's just both lies. Everything's just lies. I don't think what they put on, bro.
Yes!
Okay, that feels so ridiculous. Better be the pink guy with the race rock.
It's like connecting a battery.
Are you trying to put it in series? The voltage?
Okay, so I'm going to comment what it is.
It explodes.
That's fine, back it up.
No, it's not going to explode.
Again, I think it's feel if you got zapped by 12 volts.
Okay, we're connected. If I turn this on.
If starts
Oh, we got power. Wait, I should have. You guys were running 11.8.
Wait, yeah.
Yeah,
Only electrical engineering.
I
In a design company, we're only provided 6 volts.
Look at that power.
It's actually working. Oh, look at
We got power. We got power. Oh.
No way that actually works.
We got it. We got it. We got it. Wait, sweet.
Oh, yeah.
Look at it.
Hey, wait, hold on. Go straight and
Does it work?
Yeah.
Oh.
We might have to come to the podcast on that.
Yeah. That's been the problem the whole time.
It's falling.
It's on the whole time because they use the wrong schematic. We're so bad. I don't want to do it.
It might be wrong, but I did 2 red wires. Yeah, no, you only did 1 red wire.
I put them in series, so they were parallel. Yeah, before they were parallel, they were 6 volt and 6 volt. But the board says so I just like realized series. And now it actually works.
I don't get it. Guys, how about we make it do this? Depending on how we finish today, the privilege will show up to come.
You might have to. You got shit working. You might have to.
Because we're going so fast though, our thing's blowing apart. We can do that in like 30 seconds. Just for manual control, and it goes so fast to the course. So we make sure don't hit the wall. We can't hit the wall.
No, I think it's
Whoa, what's this one? Because we got speed.
We'll just go half-half.
It's only one way, right? Oh wait,
yeah.
No, what is it? You're only like sandwiches. They have to name like
I only are
It's just like sing a song in your head.
what about this? Yeah.
like I don't care what you just can't do
I guess still
because
cool.
if they don't buy it.
The two.
No, maybe this is the innovation that we're talking about. Maybe that's what this is. No, you don't hear talking about hit rock bottom.
Hit rock bottom, it's how we're going up.
That's
Our face is going to be on a billboard after this.
Yo, this is actually like so crazy.
Oh, some of them are
and then that way, like.
okay.
Wait.
Make sure the car doesn't fall.
It doesn't turn out like it's something product.
I think Johnny did it when I know, you know, but no, but people have a hard
So reverse polarity that you get, check that with it does swap polarity. But when you reverse polarity, you go into the control miss.
Yeah, we can make a sandwich. Sandwich one. So
Like the idea of drinking milk.
Oh, from what I see so far, yeah, I was like, you know that's not gonna work.
Wait, do we have the most?
Yeah,
How big is the hole?
Scissors.
But wait, what do you put the list anymore? What is Why are we adding the second part? But you think it's gonna jump up the elevation?
Maybe we just retire. Like, put everything on top of it.
Small out of another size, smaller to here?
No, we're smaller. We're gonna try to.
It's over, bro.
We might actually have to go today.
Okay, wait, do you want more different size? There's more. Wait, you guys, I don't think we need to grab them more anymore. Because we can, if we found different zip ties, we can lose zip ties too. Yeah. Oh yeah, that's good.
Okay, what I'm gonna do is.
Wait, first one, yeah, first one. It looks bigger. There's no bigger one.
I misunderstood. Like, no, like, the other one? It's not like it. See what morale is up.
No, I think I should have more. Here, no, the one.
I've been trying to figure that out. He said that was some sort of.
So your iron fist is okay, then
What square bolt do you know? I've never seen a square bolt.
merges another branch.
Just have to put the shapes into the
I don't know if I make sure it's like super up.
But it's like, with some of the ones that are in the middle, so, you might not have to tell me. We could, if you want to, I could still do that, but like.
So I'm thinking first is try to zip tie all of them down and see what like how much room and how like stable it is, and if we need to, then add the set.
We'll have to rewire.
Yeah, we can also zip tie the whole set with Mechatronics.
Those two.
Once that solves our turn,
So I have different really smart
your score gets multiplied by -1, so then you suddenly like you look at that, you have 40 seconds left, and you have to
Yeah,
for an extra 40
oh, I see.
At that point, I was like, so
Make it like this.
No, but the problem is that you have so many pieces of cloth. So like this would put one actually like in the middle before it's gonna like possibly
But if you that's why I want to do L for
or we can look at LC now.
I will say though, like, interesting to but like, regardless of
Well, we'll see what other options.
Vernon, Fire.
But oh wait, no,
we can connect the batteries to the wall. It does. But then the problem is the zip tie, that thing snaps in half because it's so poorly 3D printed. So I should say the person who 3D printed it might be offended.
Yeah, right.
Master is up to date.
But as long as it's wired. If we were able to add like straight relief,
It's like this.
like, could we screw these two together and then the wires and the other thing for like that's a part. Turning the mic off over. No. Imagine my fingers a bundle of wires. It's like you know what I mean?
They're polymer, but they're like polymer
See the problem? They didn't put a fillet. It's just
holy stress concentrated.
Holy stress 90 degrees. What are they doing? No fillet on the edge. Yo, we got fillet here, no fillet there.
I wiped the ruler on my sweater in front of it and I threw it back. Pretty good. 66.
I don't think you have to do a piece. There are
I know, dude, I'm so annoyed.
other people get like
All we have is nuts and screws.
You gotta add to my count two useful features. I can show you the code. Maybe I'll make it to the left.
Actually, I learned off that.
Even if that's power too, right? If it's not the vibration is just underground.
Yeah, but because that one is on top of it, right? It's gonna add more resistance to the first bolt.
Okay, if you want me to add two, I will add
Oh no, I'm just saying. I'm asking you. I'm curious.
I mean,
It doesn't hurt to add two since we have so many. It's like a beef kebab, you know, the like layers of both.
So right now, ignore everything on the next one set up, figure all the hits.
don't need to do this, where it's called
And then
I feel like once the wires start crossing too much, like the tension is
for sure that's one. Then I have either these two.
We're getting too old.
This will drive
What if we do one? We're trying with 21 more now? Yeah, I'm on the ground with all. Then you know we come to the
Oh, sorry.
Wait, I can do
Actually, just give it 1 second. I'm gonna try and test. Maybe this is really
Probably don't want to.
always a spike. You just spikes on the bottom.
Yeah, well, this is the pins. You probably don't want to screw too tight. It's like you don't want to bend those.
I just call it a solid.
You can add a spacer. No. Let me show you what it is. Like, okay. So, you want to space it?
Okay, yeah. Yeah, but stuff. Okay, yeah. Cool. Is that a different size? Wait, I need a reference size. I don't know which one that is.
Because that one's like extra. Oh, yeah,
Wait, so which was the longest one?
Oh, sure.
Which one is it? Well, I also start picking it up. I don't know what that's for. Well, I dropped one of these. It's gone. I genuinely don't know. It hit the floor. Actually, no, I'm telling you. It hit the floor, and that was it. Like, there was no ricochet, no bounce, no noise. No way. imagine we had to take it all apart and it's all tight.
I feel like I'm finally starting to understand.
Like I like the wires.
You know, understand what.
So how can you catch it?
Yeah. So you're requesting then it's pretty I realized. Yeah. Why would they think about this? Just cause.
So wait, is there, do we have enough clearance that if we high tires here, we just not just okay, no, it's okay. Oh, this is so tough.
My understanding, you don't exactly get merged or
yeah. Okay. Alright, let's just start throwing the components in for now, just so we can try to
and then
screw these down.
let's say you have this big base. You pull it like whatever.
Oh, we need to look at that plate.
And then you make a pull request.
That's it.
What does it mean? So I'm gonna do that right
Hey, try that one with that.
Yeah, okay. I trust you. I think I'll have an easier time
Oh yeah, we'll let test run. Wait, can we shift this one over? This one? Or no, ours is okay.
There's no hole in there. Oh my god.
Put it on the, no, put it on the side, put it on the side.
And then can we put that bracket on the other side? You got like 8 times. Oh, yo, it's actually spiking my blood pressure saying that, bro.
This is not very electrical. You're supposed to be helping them when you go. You could.
Just imagine if it stopped working.
Don't say that. Don't say that. Don't say that. We're not going to talk.
This man, yo, put it down, bro.
What if we need to flush it? Flush it.
That's kind of
Should be a little too.
Must be space for it, so it's like.
Wait, or you know what we can do? Sure. Can we add more, like the other square brackets below it, and then raise the elevation? Right? So then the wire can go in. Right? Should we put like something on the Alright. Good time. Okay, how many? Is it just 2?
unless I alternate this because I did miss the walking.
That's okay. There's
Why?
Are these two properly spaced? Oh, add a bunch of them. Like, twist it. I'll wait for him to have it. Oh, if you have I genuinely don't know, bro.
That looks awesome. There are definitely ways.
Motor drive. Can we take these quick out?
We're fine here. Alice is just trying to figure out how to so you can help.
Oh, then like, you take them out?
I did a bunch of testing and basically proved that double front.
Are you trying to mount that like self-safe on this? Oh, you're just trying to figure out how to mount it with this?
With the other
No, I'm trying to mount it to that. The only one.
Oh, well, you mounted that one. Oh,
yeah.
probably switching the zip
Instead of having the editor,
Yeah, that's also one of them. What did you take?
Didn't you say okay, whatever? You broke eye contact and looked up at the teacher, raised his hand and said my answer.
I was thinking it before too. I was getting confirmation that I was holy villain, bro.
No, I don't think it matters. No, I don't. Yeah, so then you do that and then that just fixes the whole line. Yeah.
As long as the wheels stay on, absolutely.
I think so. Because it's so much easier.
Oh,
and see, adding this is way easier to do.
Oh yeah, me too.
Yeah, me too.
I don't know why you do
Yeah, what's that?
What you talking about, bro? Let's knock one down.
We can really hang it on the floor. Wait.
Did you get a wall? Get a wall?
Do you want it here? Thinking, how much is it?
What's that?
Ooh, you know what we do then? We pick a smaller spacer, right? Because then it reduces the bending along that. No. Who we thinking of? LeBron James? Smaller one. No, these both? Oh my God. So fast. They're bigger, but like. This small one.
Hey guys.
No, this is a different. Alton, do you know great when you do one.
There's so much you can do. How much you can do? Yeah, I can make something cool with it. I feel like I might do something.
Whoever made this geometry. What?
Okay, let's
We're just right now. We're just mounting everything on it to like the configuration to make sure everything fits and everything is like secure and.
Okay. Let's.
Oh, I see what you mean. Yeah. Screws or is it wait, red or yellow? Black or yellow? They're the same, are they not? They're literally the same. Yeah, you could use this.
I'll let you do that. In the meantime, we can try messing around with the doors. First, we're going to try and mess with the
Yeah, I
okay. Oh, we didn't even do this. We got a 40. I think Ron was just taking the darts.
How do I die?
I got so underneath. The sun? Yeah. I reread it, all of a sudden you test your fail. It's like, did they change my code or something by getting rid of those?
the master is up to date, so you'll have to.
Oh, I just didn't pull it up.
I'm not trying to add all for the second
It's fine.
But
100% Gemini.
wait, if you're adding more,
And then Ron finds a way to see the thing.
it's not a five.
Nothing.
I'm pretty sure as a kid, bro. As a kid, bro, when tiles are your mortal enemy, bro. If there's a tile on there, bro, you're not getting it off. It's gonna too sick of it. No, watch this. It's literally none of the whole time that you have the
I think you were right the first time. And then right here, it says a thing for this branch of the compass.
Yeah, I'm working on it. So I'm pretty sure the way it works is
Nothing's going right.
this separates
That's the harshest thing of the world.
Master into feature.
No, I'm merging features from
I think once merged through, it's into master from feature.
and then
Yo, we can start making Yo, this competition, the energy went from like sometimes I think
Okay,
It's not this one.
I agree. Okay, it just doesn't make sense.
Yeah, sure.
Yeah, okay, let's try.
I'm still confused. Like, did you find it
Oh, you think you can pocket resolve? Oh.
You a small scoop? Oh, no, that's true. No. But I'm saying if Ethan's too lazy, just put a smaller scoop.
Yeah. Well, like with the small.
That's true. I'm not like the super strong.
Back to pull it. Okay, so now if I we don't want to swap Billy James, awesome.
Unless they're not shorter ones.
Whoa, look at this.
I wish that tells you the little.
I'm telling you, the compatibility.
That's so cool.
I love that.
Okay, so now
They give us
it's still working.
So the thing is, the name is different.
But that's okay. I didn't change. Like, no, I we can fix. Okay, yeah. So working different. Well, that's what we should have done. We'll do it on the wall.
Oh my god.
But okay.
Oh, I know. I hate that this actually can work. I hate it. I actually
I think that's what I like to do. Because currently our loop does like so we can do a refactor.
And then you can put
Let's clean our code out first. So the three of us, let's sit together and maybe
Yeah, I'm down. Let's
the other side of the table where there's
okay, which push are we
we can make for this like the charge going this way. So then it's like
They put like 3 of this one. They put like 3 screws here for now. Because we don't know if
yeah. Okay, can we the three of us, why don't we take a second to clean? That's what I like.
So the wire sounds good.
This isn't working, this half is fine.
I agree. And also you get more space if you go this way.
Yeah, okay.
Yeah, just go. And you want that to stuff.
Away the garbage.
Yeah.
we have these. Hit the free take them out.
So this part would be the back.
Well, like make sure this goes like these two, this bolt.
Wait, grab that remote. And lift it up. Okay, that's what I was thinking, like, because with this,
This bracket before it's always
The whole broke.
Do they hold no land? No way. Ain't no
Zip
way.
tie.
Yo, someone kind of okay, okay. Oh my god. You got me like, we'll throw it away.
Oh, just hold it. Oh, just hold it. I felt it break.
Yeah.
Double check this.
You just added no fillets.
I wonder how that makes it harder.
The inside is saying, yo, yours? Is that yours? I thought that was a
Okay, like for me, like I don't really follow the table. I would like to see the weight going down.
Let's go. It's like wasted material.
Okay.
Especially when they said so many failed prints, like it's just.
Alright, you get it now.
I don't think that's gonna help.
Let's go that side.
The connectors right there, so it's put but if you go one more, then you can one. It might make it easier, so like you can hold it down.
Yeah, let's just
Maybe we should just put the Arduino on here, so they can mess with the Arduino and like test the assembly.
Okay.
Could we, guys, can we just like use like our Arduino space and then give you a bunch of
This 4 hours. Yeah, so it's the main.h, whatever, main.h, I2C.
Alright, you wanna cut the something wire then?
I had to move this library here.
SRC?
Or I'm not sure, in lib. It made it work.
It looks fine. It should, I think, probably be in lib.
Yeah. And so, very briefly, source. So, this,
Because he wants to take Arduino so he can test it.
So yeah, let's just leave the library alone. I think just main.cpp, main.h, and anything else that we create in SRC. We've got a bunch of variables for the MPU. Maybe we can move those into somewhere, but for now, let's just leave it at the top. Same thing with the initial values.
and so,
We got cable, you connect to your computer.
As I say.
I don't know how much of the config needs to go into one file. I don't think it's bad to have whatever, like, implementation in your main.
Can I have a Brent as well? Yeah.
Sorry, like, you know, setting speed back left equals 0. That should go in main.h, you think?
I guess you could have, you could have a specific,
Do you know these rotate independently?
like a motor
No.
.h or something.
The bottom, the bottom, the back.
Let's just think for a second. So right now we have two controllers. We have the joystick controller and we have the IMU.
I pretty much left.
Sorry, 1 second. What is the actual structure of the loop? Because that's important. Because we have the, I think one way we can look at
Christmas tree and make it active and tiny activate the
calls or multiple threading or whatever.
Good thing away from the power supply.
Yeah, we can run.
True. Or our voltage.
Oh,
We need optimal power for
now back to the zip ties?
Well, maybe those, maybe the IMU and the something, I don't know. But like we're gonna have multiple processes that we want to run.
Yeah. I think the, I guess the three things that would be,
Otherwise, get the latest packet. Display the order entries. Possibly you don't. Worry about that later.
I just
Yeah, it works.
Okay, you gotta stop
this is
asking
the-
these very important questions after we put things on.
Thinking of it.
Yeah, this is
Wait. Why don't we answer this?
So, we get the latest packet.
Why do we have to get
He's just asking like if you
This is cool, but like this doesn't give you anything.
Oh wait, okay, give me.
Okay.
And I would already say that this is not great because if the UP is not ready, then you're starting, right? You're breaking your whole loop. Nothing will run after that.
You can just do while.
Oh, does it depend
So it just like
backwards and up for
completely it blocks
Oh, look
and
at
makes
this.
it so
But like that's what I'm saying. You don't want to. This blocks.
But I mean, if the unuser ready, then you can't do that.
But what about for other like where we don't necessarily
Yeah, yeah. So this should go into a function.
How do you want to separate it into different modes for driving
Okay.
balancing and so on?
So I think regardless of how we physically change the program, everything is abstract functions. And you just have like if statements and call the functions. And then theoretically we could also do like the button idea, right? To change between program modes. Yeah. We could also use but I think as a start everything needs to be a nice neat little package, function, whatever. Because it'll make it easier to say, okay, we're doing this mode, get the IMU function going.
I don't know what I did.
Do you understand?
Yes, I understand. Yeah, you definitely have to be And I would definitely be careful, even when we break this out, about doing this like DMP return stuff.
Yeah.
Because if something happens for whatever reason, it gets jostled, everything would freeze.
Yeah.
Right? Everything would shut down. And I think it'd be better to put it into an if again, like try catch statement instead, where if nothing happens, then you just tell the rest of the program the motor, the IMU data is frozen. So like do something else or wait until you get it back rather than just freeze everything. Right? Because like if you're driving forward and your IMU freezes up, so you're just gonna be driving forward.
Yeah.
I'm probably not.
Yeah, that's good. Let's keep going.
But it was
Y-axis, this is the motor, this is the joystick. So Y-axis, Y-axis, everything below that is focus. So it's like,
And like honestly, all of that can literally be copy and pasted. You know this one function where you just pass.
Yeah, that's what I'm saying.
XY and just only use it to place the
You're telling me it goes that fast?
at the end of the day, so it extracts it. For example, like it's very hard to do that, but it just does. It has like just like pass and stuff, and then it just extracts the double scroll based on It is right in line with the. How do I say it? What's the great arrow?
oh, I see. So how do you set these? We'll set those.
Actually, no. You want to go because remember, I can remote into this. I have files of video players as well.
Hey, I've learned that we put like that right now.
It's 4x1. Yeah.
I don't know how I would think what's the
The main stuff like it's
That's the thought. I'm gonna try it.
Yeah, so I have you just like
The leads and about
yeah.
Where'd you get that?
Time for the yeah, just like it's time for okay. Give it to me. I'm gonna try and run it right so I can go to
Oh, they're right here. They're right here.
worst case it doesn't
Why?
best case it
Yes, go to definition.
yeah, go to definition. Yeah, okay, give
It's in upper 3D. W, X, Y,
yeah, it's literally the class.
Cool. Awesome.
Oh, you see it has a bunch of natural
sort of skipped over that. What does that do?
I like, oh, chat. I don't. The actual chat is like, you might need. Oh, you hope I can take it.
It's the data.
I thought you were saying like the actual code.
Yeah.
Like the
Spaghetti? That's why I'm saying that sounds so expensive.
Oh, there's no way. Yeah, like that. Like just being a ball. That's the coconut one. That's what I'm saying. Like if that shit doesn't grow here. Like
that shit don't grow on trees. So all this is doing is when I actually go sends interrupt to your
It's probably just sending a data packet.
oh yeah, when it detects that it sends a data packet, that's on the board side it says, okay, the data packet interrupt pin goes high, and then you have to like stop and go do that. But all this is doing
it's like the spaghetti videos, and I'm like, I have so many from my channel, my guys.
So there's no need. No, there's actually no need.
But that also has a camera. That's all like,
Yeah. Okay, before we
that also
do
has a camera.
we should do it in stages and test. Sure.
Yeah, good.
So once they're done,
But why? Mostly, we need kind of
especially the
real
motor
life
stuff, because that's mentally a lot easier to do. You get the form.
Alex, do you know where the scotch tape is?
So go to line 145. And let's walk through it. We define the variables x-axis and y-axis and we get along read functions. I should probably define a constant somewhere. What these things are, but we'll do that. So this could be in some function. And it just reads from the pins and then it writes to the other pins. And then it's got the chain else if statement that does the same thing for the x-axis. And it's just reading from pins. Sorry, it's basically given a bunch of addresses and you pin or sorry, not addresses, pins. It's reading from the pins and then writing. It's reading from pins based on this thing, and it's writing to the motor. And depending on like the magnitude, so this
yeah, that was again, that's the worst I've ever seen for any preparation.
It is completely self-isolated. So you can
I got like one of those.
Because you should probably separate your joystick in to your motor control.
Sorry, can you say that one more time?
We should separate the joystick in from the motor control so that we can do a PID input to just some generalized motor control later. This is very smart. Because rather than doing like, y-axis this, you just do.
And honestly, they actually have much easier to take out than
that is like
grab the scissors and snip it off.
Well, because what you're doing here is something where
so you have a function that physically writes to the motor.
Yeah, you have a function that writes to the motor and does all this mapping stuff, and then you just recolorize whatever you have for that function.
Because here's what I'm doing. First, we should take from 143 to the bar, copy and paste it into the file, and then do process tracing. Then we write new functions which will actually use our function. Okay, do you want me to do that?
If we can abstract away, like if we can separate this motor control to joystick, then we can just call like get the joystick input and then have control like
volunteers. Come on. No, you have volunteers.
Hey, Ethan, you want chips? Oh no, please take them.
Really big.
Low key, like everyone's working hard. I don't know if we want to interrupt them with the pie competition.
What kind of pie is this actually? Oh, I've never had pumpkin pie.
Yeah, it's called.
We never had pumpkin pie.
Yeah, that's the
We're gonna throw it at people just for the love of the game.
You should do it.
Yo, I'm ready. I'm ready.
I should do it.
$5.
I mean, you should do it.
$5 for an $18 cheap for $18 pie.
I mean, no, Mike is gonna do it.
Like I have a bunch of main dog. That motor dog. Is it possible that we get it?
Are you?
You do, because you have either speed forward or speed back. Angular
He joined. Are you ready for the hazing ceremony?
Wait, where's Raven? Raven's gotta do that.
I think it's a tire, right? It's relatively stable.
What do you think? What was it?
Where's Raven?
You want to do the announcement?
Oh, God. Oh, shit.
In theory, it should be something. You know, I'm not fully sure actually.
Just for this.
It's Pi Day. The way it works is simply if the x-axis is beyond a certain yeah. And so we can fix that.
Test. All right, party people. It is Pi Day. Woohoo! Anyways, so we're gonna have a surprise competition. Whoever can name the most digits of pi, you get a pie.
The whole thing.
In 5 minutes, you get a whole pie. It is a giant pie, but it's a free pie. You can name digits of pi. So, in 5 minutes, those who want to compete, please commence forth.
We just call him big.
Where's my stuff?
Even the battery was on. I just started like working on like. No, I'm joking. The week
Hit the gym with me someday?
Yeah. Okay. Yeah.
Right. Just go on.
No. I thought it was dope.
Win the pie for me? I only know 30. It is a worse than Dave. Okay, then why don't you game? How many Dave keep? Yeah, do the pie. We got 75, got 30. Maybe one did three.
Pie for pie. Pie for pie.
No.
Pie for pie.
Oh, what's up? No, he's definitely fighting in there.
You win the pie for us, and then I bring some to work.
Yes. Long time. Yo.
I'm right happy too.
Where's my phone?
Yeah, he's strong.
Everybody plays football.
All right, 5 people.
It's like in 5 minutes.
Yeah, I'm basically.
Okay. 1 minute warning, everybody.
Well, no, the problem is, I know how to, like, go files.
I only remember until like
main.cpp, which relies on main.h,
like the first 9.
and motor.cpp also relies on main.h. And motor.cpp. Okay, there's one thing that applies to that.
Define them as motor dot.
But main.h.
Okay.
Main.cpp. These are good.
Okay, well, when you...
Well, I want to make sure that I can just like run it.
Okay, no, I just mean like, can't you include main.h and motor.h? So that you're not having these lines of loop.
Well, I think so. But what I did is in the .h files, I used to say if not defined motor.h, define motor.h.
Let's go.
So that I don't know if that would bar a second C++ file including this header file. You know what I mean?
That's so.
Yeah,
I'll melt the other more.
Was this properly wrapped?
I see it.
I need this.
That's how we started.
Okay, yeah, you don't think you're dead.
I miss Patrick. It's so sad that he died.
No, I think like anything past like
In a different realm up north. He went to the big oil rig up
Yeah, win the pile.
Like, we need to check. Gonna touch.
oh, but you maintain various but that's way too slow. I think we should just focus on two straightforward six.
Yeah.
All right, all participants, come forth and do not bring a device.
Let's go, Gabe.
Okay, you got this. Yes.
I don't know enough time.
But how many people? Yeah, Hangout CPE.
I only know
We have right now. Honestly, don't even need it. Yeah, it needs to be otherwise it's 65.
First person come forward. Oh, okay, we got Suckman Park. Let's give him a round of applause.
I'm not winning the pie, but if you do it below me, just like you could just take a seat and just run your seat across your
Yeah, so it's
3, 4, 6, 5, 3, 5, 7, 9, 3, 2, 1.
Or should I put it in?
8. No, it's okay. I just roll up 3, 4, 6, 5, 7. I'll be back.
Alright. Okay, let's boo him as he goes. Boo! Alright, who's next?
I don't know.
Oh no. Alright, come forth, come forth. Who are we here with today?
Gabriel.
Let's all clap for Gabriel. Let's go, Gabriel!
Ready? Yeah. 3.14159265358979932384 626433832 79502884 19716939 373
It was not 75, Aldrich, down in front. Alright, that's why I turned up the count up a little. Alright, come forth. They're just writing down where you left off. Apologies. I guess we'll have one next. Why did the chicken cross the road? Boo, I didn't ask you.
Oh my god.
You get to the other side. That was a real snapper. You slapper. Alright. Okay, we're gonna wait for 2 seconds, Aaron. I have more jokes, do not worry. Shut up, Aaron. Does anyone have a joke they would like to share with the class? You! I didn't ask you, Aaron. Any hoozles. What do you call a cow with no legs? Ground beef! That was hilarious, eh?
We can put it on the back side.
Yes.
You got it?
It's so bad.
Yo! Yeah. No, that's actually...
Yeah, he won. Let's get back to go. You got like you find out he made it up to there. Oh, okay, I'm gonna have a chance to get this one. Ready?
I didn't remember going up to I actually don't have...
Alright, we're ready for the next person. Who wants to go? Okay, come forward, come forward. Let's give a round of applause. What's your name? That's nice. Let's give another round of applause. I feel like that wasn't very giving. Are you ready?
Hey, but now for that,
well then how, what do we put him in like there's no good way.
Oh yeah, no, you got to hear it.
Instead of saying 5 times
Trying my best at it. What if we put it up so it's like
Pretty good. I know, but
trying my best at it.
hesitating.
What if we added something else? Like, I don't know how that's all. I might turn it shit. Cause like putting
80 to 42. No?
Well, this is incredibly humbling. I only know like two. I'm not very good at counting. Anyways, who's next? Okay, come forward. Let's give a round of applause, everybody. You suck at this, but who am I here with? Annie. This is Annie. Everyone clap for Annie. Let's clap again.
And then check.
Not too fast. You want your points, eh, bud?
All right. 3.1415926535897 323846264338327950288841692388416926846 264338837993751057209
Let's give a round of applause for Annie. All right, party people. Who is next? Ooh, okay. Why aren't we clapping? Come on, let's make some noise. Who am I here with? Lucas. Lucas. That's a W name.
3.14159265358997932788998620862089986280899862808.
That's rich.
Did I mess up? 825342117067982148 0865 209. No, that's not.
All right, who's next? Is anyone else? Oh, Lucas, eh? That's your name, right? Okay. Is anyone else? I know you want to do it. I know you want to. Let's get it out. Let's go, Aldrich. This is my 260 lap partner. He's to go. Aldrich.
Spoke for me.
Yeah.
Okay.
Also,
3. Point 14159 2653589793233846264338327
Who's counting? Oh, okay. Come, commence form. Let's keep clapping, everybody. Who am I here with? That fourth one, I'm feeling tough. All right. Is there anyone else? Oh, come. Who am I here with? Let's start clapping, everyone. Clap for Aldo. Okay, let's go, Aldo. You ready?
2.1.
Almost. You round up a little. You're almost there. All right, is there anyone else? Oh, is that a contestant right here? Aaron, come here. You're competing now. Let's clap for Aaron. This is your ESS external.
Wait, did dishes of pie?
Yes.
So pi only has 10 different digits. So it's 1, 2, 3, 4, 5, 6, 7, 8, 0.
That's enough out of there. That's enough out of him. Let's all move. Is there anyone else? Okay, that's everyone. Let's tally up the results. Lucas, you win. Congratulations. Lucas. Is there an A in Lucas or a C? How many digits is free? What? 111. 111? I can't even count that high. That's it. Happy party, everyone. We really are a bunch of nerds. You're all a bunch of nerds.
That was in single one. I don't think
Zero mountain. How much, vehicles out of
You can make it longer, right?
What did you say?
I was thinking like if we put this one up.
Yeah, you did good too, though. Yeah. Yeah, I got it.
Like I'm saying that it's like if you feed
Because the only video that's not even a wire throwing up my nose. Why do we get a Oh yeah. How does it it'll be like
I mean, how many? You should have done it for what?
It's all good. I did the last.
Is it working?
Is there ways that we can start mounting some stuff to test if we can drive probably?
There was no
Okay, wait. Where's the Arduino? Is right here, right? Oh, right here. Right here?
Can you serve? What do you mean?
I got you.
My code is
I can
Yay!
What's up, Alex? What happened?
Oh.
How are we gonna
Are you going on a walk with them? I thought you said you really need to walk. Oh, well, basically we have this top work so we can mount it on Yeah, that's a very sweet spot. You have any idea? Yeah, I think this would work the best, right? Hold on. The only thing is, I wish that this would go on the bar. And then, yeah, you can put it this, because then it can fly. Yeah, I think it's going to stay here.
I think it's possible. Hold on. Do you have like a... You only have here.
Is it?
Money spread right now. I don't know where that works
I might have to overtune it.
Did you guys figure it out? Last year it was pizza, this year it's pop. Oh, like it's a kid.
Yeah.
You have to yeah, you have to I think it's kind of like the door is like someone took it?
Oh yeah, oh like a slide and slide. Yeah,
You know why?
Why?
The hot end was clogged. So I clogged. Yeah.
So the problem this whole time is the nozzle was blocked.
Yeah.
Alright, that makes sense. Oh, right there. But no, we broke these.
It was also clogged, so we have two.
Nice, everything broke.
Yeah, but also
So it's literally just
Oh, you saw
Well, like, yeah, try to keep it off. So that, like, at least for a little bit, basically what you do is you find nothing to see that when you make your turn, it's like you're facing the wall, and you know that the path is this way. You turn, or you like center. You think you're centered, right, over this direction. Okay, when that you turn, you're centered this way. And you drive forward. You can see it. The distance is and not like you can just like give it a little bit to the right or left. But what if it only turns like 7?
No, not really. What? I can't hold it together with hopes and dreams.
Wait, why do you lie?
Are you gonna lie again? Yeah. I don't know. You think I would lie? I would never do something. Well, you just told me I'm willing to go. Were you lying that you love that lie? No, I guess. Ask him. $5. How's it look? Yeah.
Co-op search. Oh my god.
I have one like that.
Don't not the J word.
That's a J word. Don't say it. You should have saw it. He bet him $20 that he could finish the pizza in 4 bites.
Did you?
He finished it in 3.
Can I see? No, I think it's video. I feel bad now.
You should have saw it, bro.
Dude, I'll get you another slice. I feel queasy from it. Yeah. I'll come by tomorrow.
Can you finish in 3 bites?
I think that's but it's like the top one.
Me too.
Amen, bro. I'm gonna speak a lot on the melted steak.
Enough of you, bro.
You know what? It ain't broken yet.
If it ain't broke, don't fix it. Spacer matches.
It's fine.
What if we accelerate so fast and snap off and
Oh, no, I just realized. I don't know, the bending stress is kind of high.
Wait, or we can. Oh, you messed it up in front of the camera.
Plus, we need to reflash this. That might attach to the material that have enough of it. It's a fractured brittle.
I think it's all this is solid. thickness helps. Shear force, if you have two, the cross section area is more cross section area is stronger if you feel it. You have more than 2 friends. I tried.
When I go backdrop, it'll be a long way. I mean, you was my friend, but you didn't realize.
Like, you know anyone? You know anyone?
Я могу только...
So how many friends is that? And how many of those people would you already know? 2 or 3? You knew Katie. You knew Katie.
I made 4 friends.
You were close. You were close. You were close.
Powerful. And specifically, you haven't failed in one department when Windows runs. Not bad.
Are you doing that?
What the?
If the double I think the drive guy, but I can
That's a reg. Holy handyman, bro. Wrench and one. Complex screwdriver. I can't lie, bro. Being a big smaller now would be so tough.
why don't you define only
No, I was like probably like more conventional smaller, like actually being in field work. Because then you get so much being able to screw something.
I don't think it is. I think I started with that with
You're chilling in. It's like I just spam because of all
Space! Took over this whole
holy starlight. Yo, not round up, bro. He started jumping well, please don't tell me to orange.
I can't take it. My stomach cannot handle that.
Yeah, I'd rather just get this. You maybe you. Like, are you saying the grade don't?
that different type of sensor? Like,
That's why I'm like, okay, let's try switching the stuff. Hey, I found it!
so are you using this one or this one?
This is like
Oh, this is the reading and interpreting this for you?
this right here, it just sends like a frequency. It's just like a sonic signal back and forth distance. And this is also like where we are in space. Control the temperature so we blow hot air on it and use force. What did you say?
Okay, anyways, it's the wire.
Are you familiar with that?
Stop it.
I'll get a pin number for you.
Holy balls, bro.
Okay, we can just wire the battery.
The motoring board.
These don't all need to be in.
My friend said this was a hole, and I said it was hard to cut.
Those are the,
I guess what you do. Yeah.
Wait, hash is uploading. So does that mean right now it's just the gyro? Do we need to have a code for movement in the gyro?
Are you alive? Yeah? Seems fine to me.
Make it drive.
I'll hit a button, see if that helps.
But we can have the gyro
Working?
and the...
Make the USB be really easy to get to. You have to like upload them.
Yeah, we know. We're really going to
I don't know how to make it. I've had it before, it was good. I don't know how to make it.
Which one is the camera board? I think the one with the two wires.
When did that happen?
Oh, you mean the other cat. The one with one wire.
And then the right is... Oh,
Yeah.
that side. This would make the right side...
This is just like the frequency rate that you saw. The frequency they were communicating on the device rate. If this does not match,
because I know what that's from.
then it should not. And then I don't know the copy paste whatever.
This only that because it's so sad to say this so see like two people yeah, look, two people sitting right across from each other facing each other. But no matter how much they can move, since they're moving together, they'll never reach each other. Holy bro. Holy Romeo and Juliet, bro. Bro, what's
Yeah,
I don't know why I'm looking at the most.
Yeah, I should do it.
no, I just
I don't remember which way I wired these.
Yeah. Legs or upper? On the legs? Grab that. What do you do for legs?
I don't do KM.
No, that was like...
No, that's actually genuine.
That's genuine.
I actually do. That's actually my work.
Great, the good one.
You don't do conventional studies?
No, I don't do back. I do like a back squat.
And then squats or hack squat. Yeah, I'll be training barbell squat because I'm training for some strength. For the so I'm
You're like, oh, did you make sure the part is back to us? I think it's going a bunch of and also your erectors in the back. What? Your erectors. So true now.
I have muscles.
The boat was like, whoa. Whoa.
Is it problem?
You don't remember how to
There's no question there. They kind of like fall out, which is a problem. Except for mid-drive, like it doesn't. I do that. Like, boy, no. It's okay.
You want you to take it for it or? 7:30.
Yeah, well,
I was gonna go 7:30.
Oh wait. Oh wow, so it's gonna be walking. Yeah, see that's what I said. That's what I told you.
Chris soldered it together.
Make sure that was actually I'm sure. Have to come back later and be like,
We got our internet. This is because I guess your egg is like for the same price. You don't have 2.5 gig internet at home. How would I know? No, it's free. Sorry, it is free. It's full free. No, 3 gigabit. I don't have a 3 gigabit capable right.
Tomorrow. That would have been like what, 3 days recovery already? So like,
yeah, $95 a month.
I'll borrow also.
Tell us.
Yeah, sure.
Yeah.
Push on somebody do it.
Do some legs, do some
You have time to.
yeah.
Oh yeah, you have to renew every 2 years. Yes. Yeah, that's the problem, because now we're almost at the max.
No. Let me think. The thing is like, when is the?
Yeah.
When is the race?
Because we upgraded, they keep giving us a deal. We haven't increased the price probably in 6 months. $95 a month. That's the only reason we got it here. Not the 3 gig. I even got, I got a new Unify router.
Oh, it's white.
Yeah, another access point.
Oh, so like a 230?
Oh, yeah. It used to be in the other one.
Oh my god. We're connected.
I 10 when I was 6.
We're not connected.
Yeah. The engine sounds great.
Can I have it? Like, sure.
Is that what you want to do mechanic? Or no?
Yes.
So I took it to the thing in Airbnb.
Would you want to try to drive with F1?
I can have one. No, nothing. I paid my own.
Yeah.
I had really good Wi-Fi.
But you need some.
And I had a router.
When? I mean, yeah. Like, I know like some people they just. And also, you lower the power.
You think you can buy a kind of
Right now, the top
say like 5-10 years of your career.
Yeah.
You could do one of those cars.
Take that.
Or what do you think of other cars?
And then blocked out your stuff.
Right now, my dream car is
Like sitting all the way in there.
color? I thought you were saying which generation. Okay.
Oh, color. I don't know what that is about color. I know like the generation.
Yeah. I was like, cause color. I would say gray and bluish.
Gray.
Gray, bluish, and it was a little bit purple. So it's kind of like.
Because like I don't actually red. color.
Yeah. Oh yeah, I was thinking that color in my head too. Honestly, I was thinking black might be nice too.
Yeah. It's like it's like it's a color that's okay for function over time. Like it's hard to say. Like
Also, like when people see you, they don't know you're color, right? Exactly. See,
it's like it's a color that like it looks nice like function.
Yeah, that's
some girls like doesn't like black. Yeah.
So that's great.
Yo.
I need to see how that's ball. Whoa. That is a loose girl. Alright. Take those guys.
Yo, what's up? You want to hook up today? Yeah, I like C7. C706. Yeah.
Turn the motors around.
C7, I don't think.
Oh, we probably do. And so backwards.
You got orange too much. C7, that's a stinger in this. Oh. C6 is just temporary. It's not really out. C7 is here. You're a C806. It looks the same, but it's a little bit. I think it looks the same. The engine is different and a little bit smaller. And if you think of a CR1, yeah, it's a sports car. That's why Corvette is like a kind of like. There's a Porsche. No.
What is this guy that's a white guy who just bought a Lamborghini Urus at 20 years old because he was like really awesome and he was total car. But he was also like, or like, kind of how things like.
Yeah, it's like, I mean,
you could that one's too easy. Hard to cool world.
I can help you with this. I want to see how you set up the, like,
wait, I just said something that detached it.
No, I think
No, because my mom bought my brother a car.
Yo, your mom?
My older brother. One thing is, I have two brothers. Yeah, I have a younger brother, I have a younger sister.
Yo.
It's the half family here, right? So I only have one full thing. My second older, like, yeah, my older brother is my full sibling. My oldest brother is a half sibling, and then the other, but that oldest half sibling has the same name.
Yeah, see, that would work too.
The younger two
It's Max only half of it.
Right now, you're going to the camera.
No, but that's not look at the price. She bought it like 20.
So, yeah, because they have a USB-B port on the Arduino. But an A to C adapter.
It's an old, right? So I was like, she's still I mean, she financed it. But the thing is, she
I don't know where the hell it came from, but I have a USB-B and a C cable.
Yeah, I like him. But this is
It's only 8, it was 8.
There's a little spoiler and a little bit different. I think it looks nice. Yeah, it looks really
I can bring it.
Yeah. I'm not a huge
think that's a, it's good. I think yeah, I've seen sometimes.
I would never buy it. Because I think there was one, like I'll do a dark comedian.
Okay, I see what you mean. I see what you mean. Well, I would say it's a very nice toy. Porsche is amazing.
Yes, it's very
Unfortunately, the access to take it is too much. That is basically like a racing car.
These are so tough. For now, but that's the next generation of 3D printing. Next, you're just gonna make this out of carbon fiber. What about 3D printed physics? Oh wait, did you post this?
I don't think you can rotate it. It's too small, but yeah, it's fine. It doesn't take that much time.
What did you do attach this? Is there axles?
Yeah, it's like a, this is
When I was young, I loved some of all.
yeah, I still have all the Hollows. I love Hollows. I like it, Hollows, like right now they have like a premium version, they have RLC. Yeah, it's like Hollows, right, like the Hollows, like mainline version uses tires of plastic. And yeah, the mainline version uses tires of plastic, but the premium version uses RLC, Hollows. And in mainline version, there's the treasure hunt and super treasure hunt, like
So basically, this little block.
I mean, oh yeah, but right now I'm buying like a couple, like 3 years.
So brown pin right there.
I can't. You guys see the.
I think we need to. I just want to keep it
Computers have flame right here, so it's like it's rubber tire, and the texture of the yeah, what they call like a spectrum flame. So they have like a higher quality texture or something.
It'll be consistent. I'll probably see it in person.
Yeah, you can just see this is like
what we can do, I think, is we trigger
it's really hard to find. That's crazy. And sometimes depends on the car. Oh yeah, like just like this one. This is really some car looks really cool. And this one, they just sign like a with Ferrari and this car looks it's probably like $1,000. I mean, my mom has like a Toyota Camry, but right now I have my friend right here. I don't have like a SUV. Yeah, like small cars. Yeah, this is like RLC. This is
wow, the color.
Yeah, I know. This is like a often it's like limited. Yeah. So it's like, and you have to buy the membership like every year. Subscription. Yeah, subscription. So it's like this card. This card. It's like a membership card. So it's like you can get like a $12 for like a full year for like a membership card, but you can pay like $39, including this card, like
the tape actually works
card, the dealership. Yeah, this is like a membership card. So this one doesn't technically have like a limited amount, but for these, it
Well, it's a blue color, 134. Well, I guess that's in the... Yeah, for real. Oh, this one, this is like... This is like one versus 43, so it's like a bigger size. And you can
Yeah, but I won't do full, so.
twin turbo,
And Lane will be here tomorrow to do the rest,
That's
so
like a $30.
I'm just coming today. Because he's gone, right? So.
Yeah, but it's like for a Hot Wheels. Yeah, and
What?
oh yeah, the wheels are both It should go this way.
They're separate boxes.
Because I went back and suddenly it went forwards.
Purely on the converted to $80, it's probably
Yeah. So maybe we do separate into
oh, like $60.
like I think
Well, it's not our fault.
Almost 7. Around there. But that's what that was like.
so
I'll put this all.
This is like a
yeah. Oh, so these are yours. It's like it's all blue. So I think that means good. So it's all
Oh, I know. I saw him the other day.
yeah, he's like they were actually doing that.
I know he likes so much more, and he saw him watching. I know.
Yeah, also
Box of boosted ones. And then we're like, it might be like, yeah, that's so fucking funny.
just missed Ethan. He's like, he gets to Alex, I don't know where he is. And I look up and I see you. What's your stuff called? That's it.
I think it's
If you're gonna be that, you can work here too. It's not. If you're running an event, you have to be present at the event.
More energy storage.
Roughly.
The same job, which is like super important.
what's the point of the sensor? Like, what's the No, I don't know if it will not work like this will work. Because, you see, if we put this on the top, we have full space at front. Right? Like, we can move the thing like, to the back or maybe a little bit to front. Like, we see some
like insulator.
So it's a tilt to the
So if you imagine two traces running out of one, put like let's say along the top bar. Me too. The orders and you generate it. But if you put higher down, we need to require more energy on those traces in order to generate. You won't always have.
So maybe we could drop the wheel. Genius! Drop the wheel. Make the extra little bit. So it goes straight.
And then the wheel require more charge to generate the same expression. And so if you think about it, what's causing it to you don't want people to come with it. If you and I think it's just these like
Yeah, so it's not. Oh, this wheel is tilted.
So it's like not spinning as fast.
We have to figure out.
But that's not the worst issue. That's not the worst of our problem. Like, you said drop to remain kind of pretty good. But I think that should be improved.
So that's important. The air is acting as a dielectric and the air is a dielectric. I got it. So yeah, basically it's basically what's happening here
If you want to crash or you run out of
bring them further and further apart. And now the electric field is smaller and air is but you still feel it because air can flash right into that current flow.
I'm also thinking about this. You know what we do?
I'm starting to get really tired. I'm starting to like dread. Just like this stress, like, oh man, this is fun. We're right back into this.
lot of standards, like a whole bunch of things. Like a shit ton of these. They give us these and immediately my productivity is down like 70%. Like, they hear that.
Wrong time. Wrong time.
We're not nothing printed by Tuesday. These are silly. You can have plug mine. What are we printing? Yeah, I saw them on the 3D. Just done like 3 hours. I'm just gonna put it over there. So this, because I know it's sitting over here, so it's gonna make a storage size.
We just switched the wire. Spent hours on that shit. Given my reputation of watching,
Remember, there are other plastic parts trying to
like, I can like finish making
Big Man Lasso and walk in.
It's fucking Big Man Lasso.
Hey, we're gonna look at the lens, but
yo, how are you? Based on mine, I feel like she's just gonna freak all of not and that's gonna suck. Oh my god, this shit's moving too. Oh my god, I should.
Hey, the amount of hours I spent on it.
Grab another mic.
Get that turn! Get that turn!
Yeah.
Yo!
Oh, you're putting it away.
Oh, shit!
You need to run the calibration programs with the
That's our biggest issue. Why are you coming on? Oh, wait, what is up? We don't judge it. We don't love it. Remember, guys, code is not the problem anymore.
What we can do is copy the file into our by key. Yeah, just watch it. That's probably easy. But the thing is, I'm going to use a reference as well.
And it's referencing my
Well, it's telling me it's yeah, because then we can run it alongside. Go to the top of the wall.
like with the BCC cable.
I don't know.
Tender moments.
If anybody's stressed about shit,
Read more circle. It's a standoff. More circle. Calculate that angle of principal stress if there's no shear. Yeah. Whoa.
Yo! You don't have to make that sound, you know?
You know, for a second, when you jumped, I thought I was gonna draw.
I felt like I was going to draw.
Some
Cover. That's just not how you start tight fitted.
Your job, bro. Enjoy.
But
yeah.
Five?
Yo.
Don't compare, bro. It's okay.
It's mechanical. So you do have work experience. Oh, I have work experience in like not engineering. I've been a server. I serve alcohol and stuff like that. Work at a beach house. Do some of the flowers and whatever. Work at a beach factory. So because for them, what they wanted to make sure you could work long hours. That's what they said. Because that one is like a labor job, right? You could be out in the field, right? Field technician. Field technician, right? So they want to make sure you could work those hours, right? Because they asked me, like, they're like, oh, like we saw that you worked in Ontario, right? What were you doing there? And then I was telling them like my mom is a contractor for one of the factories there, right? So I worked there, right? Just worked. And they're like, oh, you work all hours? And I was like, yes, I work like 5 to 7 days a week, and like probably like 10-hour days at least. So, and they're like, okay. And then they're like, oh, if you get the job, we'll call you back in a week. They called me the next
Oh,
week.
no, sorry. Leave that like that.
I'm very grateful for it. That's worth it. Yeah. Because a lot of them
Plug
want
in the thing as well, just so that we
if you're doing those things. Then I get to drive a pickup truck.
So,
Just curious, what's this event?
Remember?
Aaron, come over here.
Why you called me?
no, but she probably
Did you know Francis is retiring? Yeah. Retirement. Yes. First week April. Was it first week April? I gotta ask stuff again. I asked stuff again when it's specifically.
Next Thursday? Okay, that's good. No, I think. I don't know if this pizza enough. That's not up to me. You can ask the big dogs. I'm doing nothing right now. Like, what? A co-op? Yeah. Like this is my events basically. This is my events. Well, like I was supposed to be like one of the lead organizers, but like my skin kind of got bad, so I kind of like couldn't do too much. But like it's going on. It's not bad. I'm still doing bum nothing. Bro, actually, my supervisor. No, I thought a couple weeks ago during their complete team meeting, my supervisor was complaining that DDR, specifically Happy, is being too harsh on the first circulation, the first round. Okay, Erica saying like, oh, you kind of have to be harsh.
It's one of our more popular.
Yeah, exactly. But like my supervisor was saying, my supervisor was like, oh,
it's a lot of work.
We're good. Wait,
just hold it up and see. It's once a year.
It should just be like all the highlights. All the this is not No one's watching. No one's really watching. Is anybody watching?
Yeah. Right now it's not immersed.
No, it is. It was.
There was.
Alex, there was.
Yeah. Okay.
We did have pizza.
Do we still have pizza?
You can have one of those if you want.
I see there's one for us.
Nice. Full of tongs.
does change. Disconnect here.
This is like the fourth cup.
Yeah, we can do 10, but it's a lot harder to do.
Yeah, that's what I was
I will, but I'm thinking.
Yes. Oh no, it's You want a half-empty Coke?
And then the battery can actually will be kind of hard to take the battery.
This is what a full one looks like.
So why do we need to take the battery? Why do you take the battery out?
Also, I would not have thrown a full can out.
Oh, you're gonna
So that was why we
and then, okay, then you just put this one.
Yeah, I'll put it here.
Yeah, that's all.
Okay.
That's what I was thinking. I think here makes the most.
Okay.
So first, yeah, do we know here? Go on top. Yeah, and then we make sure there's clearing in the front for the eyes.
Oh, we didn't use it.
You just make sure that it's
Just put it down.
Back to the workstation.
Wait, actually, let's unwire everything.
Scissors. Ready to, because we need to cut this chicken, right? Like we need to cut all the oh yeah. Yeah, we don't need to for these, but for the side. But these two on the side.
same robot on all of the sides.
I don't want that.
Why don't you put it on your setup that it freezes?
Yeah. We have to like
And not set it on the laptop.
Do it. Then when I put them out in 5 minutes. Yeah, because like honestly, I might as well just go first of all. No? And then we go celebrate like going to do it. Watch it.
we sell the microphone. Where's Rod? Pack and ETLC?
It's true. I have. If we're walking in the back room as well, that's how you get the food.
Sure. Grab the ETLC. That's like,
Wait, and then after are we gonna try to fix the inverter controller?
All the bits are underneath.
You know what's crazy? Is that they did that and they didn't think to put the bits back.
We can't lose these bits.
I actually do. I have to. And as long as it's driving for new, it's fine.
You know what? Let's stick it out and leave, alright?
Yeah.
And then we can see if we can. Keep on that.
I don't know. You saw that, right?
Gosh, have we considered this? This is a very low size.
Okay, let's take this part right off.
Just to let you guys know, though, these two are optical. So
Yeah, but once it's in the middle, you don't have to. Oh.
Yeah, we can use the one, yeah, that one. We can do that. So the battery will actually
I think the video of this unit is awesome. I want to go too.
No, we already know.
That's true, yeah. Oh yeah, yeah, we can, yeah, I can.
Oh yeah, I was working on that. That's true.
I don't think that's necessarily true.
Who's the strongest person you think of right now?
Oh no 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 no! I was thinking. I was thinking. No, I was thinking. No, 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 no. Sorry, I was thinking like I thought he was asking like who do I think? Sorry, I was thinking. No. Well, I mean. No, no, no. It's the short Chinese Olympic lifters from. No, have you guys seen the Chinese? Have you guys seen the Chinese Olympic lifters? Like the powerlifters, they're actually like nobody can match them, and they're like all like 5 years old. This guy's just being humble.
So, but look, it's getting.
Okay, let's check if those pins are actually going high and low when you try to do different things.
Like a sheet metal, motor sheet metal. And that one's the sheet metal. That's what I'm asking.
There's another screwdriver. Yeah. One further. Hands off. Buckaroo. Okay, the thing says we can't. Okay, we need to take these two. Like these two.
That might be.
These two for the motor, right? And just take the motor part. Do you want to take it off? Wait, do you want to take it off? Do you want to take the wire off?
We need a
Do you want to?
wire.
Yeah, what? Take them. Do you need to take these off or no? Just hold it. Take them off. Take them off. It's not a push. Oh, they're connected. You have to screw them off.
Stop.
No, I'm seeing this. Yeah, you can unscrew it. Oh shit, how did I put this on there? Much fun behind them. So you need to take these off as well. Okay, let's do it. Okay, so you remember which one connects to it, right? Yeah, we have the instruction.
What actually? What was that for? So after the allegations, bro, you're not beating them. Yeah. Accordion slip, right? That's psych knowledge. That is psych knowledge.
Oh yeah.
Sweat? Yeah, it's hot, right? I know.
So his hands are cold.
Yeah, he's too
How cold your hands? His hands are doing this. Hey, you can compare hands. Can I show? Whoa. 1, 2. Cash gotta do the thing. You gotta do the kick.
Get back to barrel.
Right, Kaylee? Have you ever done that to Ethan? Where you're like 1, 2, 3, 4, and Ethan goes like this? Yeah, you haven't seen that meme? It's like this girl sitting in the cashier, right? The guy sitting beside her and goes to like touch his shoulder, and then she jumps, she goes like.
this one was pretty good. So we need a distance. So I don't think it's gonna come. Can you put it here? You want to put it? I think that looks like almost 10 years. Wait, what was this one before?
That was just like the whole table, so it didn't hold.
Okay, so we can still put it. So do you want to?
Yeah, one up.
Oh, wait. No, you're not please. Sorry.
Oh, that makes sense. So we can get out of here in a time limit.
So the whole thing.
Yeah. All this stuff is going back in. The gears make sense.
I think we're just trying to make it back.
If we put it this way.
Oh, you can flip them?
The older one.
No, I'm saying we rotate the forward.
We go forwards. Isn't it
No, like, yes, this is the hook.
Oh, yeah.
The hook. You see that? So we have more options to, like, we can, right now we can only put here, rotate like this way. Yeah, I know, it's so stupid.
Or you can go backwards. No, the right side is good.
He had so much hope for us.
I had a hole. You know who taught me that? Dad?
Backwards.
Dad, you know who taught me that? Superman.
I love Superman. Yeah, so what do you think? Like, do we need to, don't we need to, like, it's not that bad, but it's like, but honestly, if we put it right in the middle, oh wait.
Because like, you know the middle part, when I go forward, it goes forward.
Just needs to be more gentle at the
Right side.
I wonder if we're rewiring stuff, like hit the switch for the X, Y axis.
I have to see how this wheel
I can leave it alone.
I was gonna say, I have no clue.
Okay.
Serial monitor, and it's not gonna work.
You have some magic and then quicker
I swear to God.
What's this?
You have long black watches.
Okay.
It's in the spawn. I think your based on size too.
In a good way.
I did get a haircut started this year. I did look top.
That's what I'm, no, I
Get a haircut. You never
so like I'm
You ever read
magnetic stuff. No, but it doesn't make sense to try to learn.
No, I haven't. I'm gonna be flying.
If someone else wanted to get
Okay, remember the day when your parents told Patrick to fly?
You're on your own, buddy.
Okay, turn off the... Right turn. You go Patrick, rookie slide.
So the back left, so this is
So do you want to change the
back left.
orientation?
Like, are we just gonna put
where does it go from?
Yes, in case
Oh, it's right here. Oh, it's here.
way more of
Because
I don't think it's that hard.
Would you like to
So we want to.
you want them oriented, like don't walk back.
So you used to have more choice. Yeah, we have more choice. Yeah, so based on.
There's a star. This one goes here.
Yeah. So we just want to rotate the.
This is the direction we're going, and then mount this way. So it's like a finger.
No. Okay.
Is it going that the wheels here? Because you see how vertically here there's only so much space. Look at here, there's one like here there is not like
So we have a lot of choice to like put this
yeah.
one. We can put here, we can
Like,
put here,
if we put it directly in the middle, maybe we don't have enough space for something else.
Yeah, that's right.
Yo, one of these
Like a spin
Do you understand? Like,
one of these can be a star then. Like
Weird dynamic.
I was thinking like slow the technical. I don't think it's gonna work out. Like greedy.
yeah, where is it coming?
What?
Iteration.
Yeah, we just Control 6, VR.
We're doing VDI 2206.
Why am I surprised? Why am I surprised? What? He said, can I get like, yeah, indirectly. Because he was like, can I have contact because we're going to gym, right? I was like, you can have my phone number. He's like, yeah, you got like phone number, grinder?
Discord, like,
Yeah, actually, this should be surprised.
Why am I even surprised, bro? That's like, I'm like, no.
So, like, I guess that'd be a little bit.
I mean, you're a man. That makes sense.
Look.
You know,
I think we've lost it.
you know, as much as it's solo energy, I think it's been so fun. I was just hanging around. You know, it's like it's so stupid.
we got power. It's always
Because of this, I told you we got the 5 infinity stones, bro.
Yeah.
Let me do it on your forehead, then you can see if it's.
We did the 5 minutes.
I get back to
Other 2 have.
You didn't do it on the shirt!
What do you use usually? I use
Yeah, it's like you were digging it into my skin. A little bit. Yeah, and you stabbed that into my spine.
It's Spider 74 pizza. Yeah, there you go. So what, you saying don't do 78? What time?
If we didn't do this, I didn't even notice.
Yes, I'll put it here.
Oh, you saw that?
Has it been broken? How long?
sure. Do we need probably not. So you want to smoke on lighter weight. Okay, we might.
Yeah, me, I don't like. Yeah, I don't think. You guys want a new one? I don't have any. That's a must. Yeah, yeah. Okay, if you're not playing creatine, like, please don't creatine don't work. You're losing game. Really, people who don't even work out should take creatine. Because there's more benefits than just your muscles. Overall brain health and all that stuff. It's really good. More recovery, everything.
Can be fixed with temperature.
It's so easy, just put it in your drink. Do you have flavor?
Just like a mono.
Hello. Okay, everyone, just a quick 20-minute warning, and you're gonna have to leave. Please leave everything here. Do not take anything home. That'll be all.
We can just leave. Now it's a challenge. When this back out, let's go back out.
No, we just leave it. That's perfect.
Well, I mean, that's what it's trying to do.
Where? Yeah. Like, you're right, bro. Fresh, bro?
Right there.
Fresh, bro.
No, like,
Oh.
For me, bro, but now I'm trying to avoid drinking sugars. Unless it's like powder. Okay, no. I don't know. Like, for me, I don't care about eating the calories, like, to a certain extent. Like, if I'm eating more calories of like whole food, like, to a certain extent, I don't limit myself to like ice cream and stuff like that. I'll do that stuff. But like, when it comes to sugary drinks, I don't know. For me, I'd rather buy sugar. Like, if I want a sweet treat, I'd go buy a brownie or a cookie or something.
Can we put the whole peanut butter in?
I can take a long time.
Can we put like the most?
Oh, we're being sarcastic.
Wait, guys, something graduating? Ryan, our sister?
She said I took a long time to get that sweet potato.
You just make it walk slower.
I'm just gullible. Gasoline for the whole time. That guy literally just lied to me his whole life. Blood said he's in 71 at the bro.
Oh, you want to like?
Yeah, no, you only do 6 if you don't graduate, you're kicked.
Like you want it like a little bit wider. Yeah, longer, right? Not full. Yeah, you want it longer, right?
I mean, I'll just graduate out.
I will put like the one with the 2 at the back, the one with the 1. Yeah, that would be
That's like tall, bro. Basically, so keep that.
Yeah, easy.
Kind of. Yeah. So let's give our stuff. Basically, there's confidence intervals, right? So say like I test this certain thing, right? I'm like 95% confident that like the value should be within these 3 ranges. What he did is he took 100,000 samples of the radii of cubic stones and he manually calculated it one by one.
Actually, that's crazy.
So he used Excel. He calculated one by one. And he went through the numbers one by one. How much actually, how true the confidence is. He said it's good.
Yeah.
Why?
That's what you sat there doing?
Oh, jeez.
That get one. Yeah.
Oh, that's so safe.
Yeah. Is this an original idea?
Wait, what? Did I just wait?
But how far is the walk
Already?
How far is the walk
We drive my house here in Lex, right?
Yeah, you can drop it all from
This location is like
oh. Now you can probably back up here at the station after. Or any station. Driving back to Century Park and stick by Holy bucket of
Holy 2000.
Well, what about 2002?
It's the fourth.
Elite ball knowledge is,
Yeah, so
just take them? Holy crap, propagation, bro. See? See, after that crack propagates, bro, see, that's where the crack propagation is starting. So what it's gonna do, so this is it's not done. It's not done. Instead, since it's weak, it can't relieve stress by passively deforming. So that's why we're gonna break the stress.
My window is
Yeah, my bad, right? Too theoretical. Theoretical. Yeah, I'll put it back. Which honestly makes sense. Cracks is a bigger crack cookie.
What are you, a hard-boiled egg?
No, that's not even what I was talking about.
So this data is fine.
Actually, bro. Game over, bro.
Nothing. It's good.
that's not a good name.
Oh, we should just give it like a.
King, no, stop!
What do you think? Crack what?
You can't, at your big age, you can't be saying that.
Minor cracks are cracking.
Wait, are there any difference between these trousers? These two with only one peacock.
It's over, bro.
So that's
Yeah, I always put two. I want to make sure. Yeah, no, I'm like the wires, the lenses.
are you sealed with quartz?
What's your favorite pump? You're lying, bro.
So you, one side is longer and the other.
Yeah. Are we drinking plastic? Yeah, but if you were to drink pop, which one would you drink?
Oh, it's not gonna work because it's cereal.
No, I just
I'm out of one.
maybe it's not
This is what actually
Alright, guys. Are you still going or should we just head out? We just head out? We only have like 12 minutes anyway. Yeah, actually, we just go. Yeah, let's pack up and head out. Because how do you have us time?
I'm going to put these 3D printed pieces here. Very organized.
What we think is crazy, guys, is that we can bring you 2 out of 3 of this challenges per
This is about, no, you can make it more autonomous.
We got more points for our
So can we make a smaller one? I think we need to turn this maze on the The balance is like brain dead. Like the,
No, that one?
manual control for the balance is so easy.
Okay, what I'm thinking though, if you're doing autonomous,
So the wire will be a problem.
is it better to code it detecting changes in Z elevation or like
Ethan. You think it will be a proper?
Yo, spikes my first I'm doing a break.
Hello, serious.
Oh, wait.
I think I might know the problem.
Okay, what was I saying about the cereal? Z translation, or just detecting changes in elevation linearly. What was that? What was that one sensor you had? No. The gyroscope.
Yeah, I
Oh shit.
Wait, I thought you were.
Yeah, I got the number. It's like I got it. So, oh,
Maybe it's the fact that this thing is moving off. Next time. Wait, when it's
so second place.
Oh, but look, yeah.
I don't know. First place was like something.
Yeah, I got the name from something.
17 order 15. Sure. That's like Rainbow Six Siege stuff. You can't do that. But then when you get tired of it, I don't want to jam after this.
No, we still need the 5 volt thing, sorry. No. You just can't be in. Because 5 volts is powering everything else.
Oh, I guess. Oh, no, but
just pull me in. Just pull me in.
It's like a piece. Yeah, I want to take all the wire. Guys, we're really organized. Yeah, I think it's very good.
I think it's a power seat. That's
I also wonder if it wasn't going to
let's see.
Yeah. It's hard. I mean, we're talking. I think that one. That one.
I do want to say guaranteed. Or the signal sounds online, or like anything else.
Yeah, me.
The thing that I'm surprised by is that it is repeatedly the same.
That's just has to make
You know what I mean?
It is like makes me to explain it.
Honestly, I'm thinking about the
Oh yeah, you wanted to drive.
In the middle. Well, yeah, you could just put the lecture, no?
But like, what if they figure out different distances? Like they may not be in the same spot.
Oh wait, why they put it? Why they put it, not us?
Are you gonna measure up? Like, you know what
you
do? Yeah, you combine it. Use the gyroscope. So what it does is that so we measure fixed distance, right? We get it like different balances. Then we use the ultrasound. The gyroscope. So as soon as it detects that it's on the ramp, that's when the count starts for that distance.
Oh, the ultrasonic detects the ramp.
Yeah, exactly.
And then it starts the gyroscope, or like the distance.
Yeah, exactly. Then it go and then you end up in the middle.
Or we can use the temperature detector, and when it gets in the middle, we just like light a candle.
Blow on it.
No, you know what we do? Basically what we do is that we make a gas chamber, a different one.
Hey, how did it do?
Wait, listen, okay? So we put 2 paints of glass, right? We put a different type of gas. I don't know, something that has a different heat convection coefficient, okay? Right? So then, that means, because we have that barrier there, the temperature, bro, I failed, bro. I failed.
Every day, every conversation.
Listen, right? So what you do is you put those 2 things, right? And then you put different kill the gas other than air, so it has different heat conversion transfer, right? So then when you cover it, so then, but basically, that group, the layer, is going to create a temperature gradient. So that means the inside temperature there will be different a lot.
fix that. Wait, right there. No, I just play a game. Yo, Ray, why you being so aggressive? Why you being so aggressive? I just don't want to do that. Yeah, man. Oh my god. Yo, he walks beside me, skin me by 0.1 plus or minus 2, bro. It's over, bro. Okay, they pop up at events randomly. First year I have shit.
What's kind of fun about it though is like if you haven't seen like the resistor and transistor size like
Good evening, everyone. So we do have about 4 minutes left for the event. So if everyone could please start packing up and getting ready to head out, that would be super helpful. Thank you.
Make sure everything is
we should
yeah, I don't know whose drinks these are. Yeah, that's not gonna go bad. This is turned off. I don't want to be coffee cups and stuff.
My dad would go well for
Go.
I don't know how
We also gotta start leaving out
Oh yeah.
Go home.
It's important to me that we lab. I'm gonna go dump it.
Okay, copy.
That's like the worst case. Literally. And then they walk this way. Yeah, like we could walk.
Which charging cable is that? Is that your cable?
Make sure you get your
Sorry, we have another announcement here. So for those of you who are fasting, we did reserve a pizza for you. So if you could just meet the brown kid right here, he will lead you to the pizza. Thank you.
Bro, holy unhinged, bro.
I didn't think people could break the fast until like 7:30.
Bro,
Daylight savings time is screwed them. Yeah, last Sunday and Sunday during yeah, like, 2 weeks ago, people were breaking their fast at like 6:30 because daylight savings time. Okay, I think we're good. Let's go. AirPod. feel sick thinking about it. I hate myself for not having stress.
What?
Oh, just last year felt like this was not.
Last year we went out to eat. We had time.
We must have finished our midterms and been done our homework.
Yeah. I swear the stocks are raised later too.
I know.
I can't wait to leave on
Dave?
What do you want, Raymond?
Okay.
Dave?
Hey, Raymond, what's up? Bye, guys. Take care.
Goodbye.
Goodbye, guys. Yeah, that's my turn. Yeah, that's my turn. They're all great. I told them that I kept one out. Yeah.
Sorry, folks.
Thank you.